Good morning everyone. Today we are going to discuss in our senior inter first topic is first unit is waves, which is having that 8 marks of weightage, one long answer question which comes in the public examination and for the 8 marks. So first of all, what is wave? Wave means which a wave a disturbance that propagates without transport of matter, means there is a matter whenever some of the disturbance is happening in the matter, that the energy is propagating from one point to the another point, from one point to the another point through the matter, but the matter cannot move from the initial position, only it vibrates at the initial position. Then always do not require medium, because of some, if we consider a light waves which is traveling from the sun to the earth, the sun rays which do not require any medium, material medium, because of between the sun and earth there is some vacuum place is also there. Due to that vacuum place, without any medium also sun rays are passing to the earth. So that's why all waves do not require any material medium. And the classification of waves means the waves can be classified into the generally the 4 types of waves. That is, first one is mechanical waves. Mechanical waves means with the waves which require material medium to propagate from one point to the another point or one place to the another place. They require material medium, like for example sound waves. For example, wherever we are speaking something, to reach the other point, there is some material needed. So that's why we can say that mechanical waves require material medium to propagate the sound waves or seismic waves or water waves. We can be tell the examples for the mechanical waves. Next one is electromagnetic waves. Earlier we have told that the sun rays are passing from the sun to the earth without any require of medium, material medium. Like that, electromagnetic waves is nothing but sun rays. They do not require any material medium, and they consist of oscillating the electric and magnetic fields. Electric and magnetic fields. The electromagnetic waves consisting that the electric and oscillating electric and magnetic fields. So they do not require any material medium like the visible light, radio waves, microwaves, gamma rays, X-rays, etc. They can move with the speed of a light, which is equal to c is equal to 3 into 10 to the power of 8 meter per second. Means the X-rays, Y-rays, gamma rays, and at the same time radio waves, microwaves, those are all waves will move with the velocity of light, equal to the velocity of light. Then the third one is matter waves. Matter waves means these are associated with the constant particles, means like electrons, protons, neutrons, like that. The matter waves consist of associated with the constituent particles, the matter which is containing that electrons, protons, neutrons, like that, they constituent particles. The matter like electrons, protons, neutrons. And the other one is gravitational waves, suggested that cosmic bodies. Cosmic bodies means cosmic bodies like produce these waves interacted with each other. Means gravitational earth feel that gravitational force to interact with the two bodies. They attract with the two bodies. So in the galaxies also, stars and at the same time planets, these are having they can produce the gravitational waves to interact to each other. So that's why we can say that suggested that the cosmic bodies produce these waves, means gravitational waves, and interact with each other through these waves. These are the classification of types of mechanical waves. In types of mechanical waves, there are 2 types of mechanical waves. Is there? The first one is longitudinal waves. The first one is longitudinal waves. What is meant by the longitudinal wave? Longitudinal wave means the direction of the propagation of vibrating particles which is in the medium from its mean position, from their mean position is parallel to the direction of the propagation of a wave is known as longitudinal wave. Means when if we take the spring and we expanded that thing and release, then it will start oscillating vertically. Means the direction is the wave is in this direction, and as well as the vibrating particles means which is having the constant particles by the spring is also moving in the parallel to the direction of the wave. So that's why we can say that the direction of propagation of a vibrating particles is from their mean position is parallel to the direction of a propagation of a wave is called a longitudinal wave. Is called a longitudinal wave. Once again, the direction of the propagation of the wave whenever the spring is expanded by using the force and released, then the spring starts oscillations, means either vertical or horizontal. It doesn't mean that whenever they start oscillations means it is in simple harmonic motion, then they expanded and compressed. So that's why we can say that whenever the direction of the propagation of the vibrating particles is parallel to the direction of the propagation of a wave is called a longitudinal wave. For the example, sound waves are the best example for the longitudinal waves. Sound waves are the example for the longitudinal waves. We can say that in this longitudinal wave, compressions and retractions will be formed. Compressions and retractions will be formed in the longitudinal waves. What is compressions and what is retractions means? If the distance between the two consecutive particles of the medium is more than the normal distance, means the normal distance of the spring will be less than if we whenever we expanded that one, the distance will be increases. So that's why if the distance between the two consecutive particles, if the distance between the two consecutive particles is more than the normal distance is called refractions, and if the distance between the two consecutive particles is less than the normal distance is called as the compressions. Once again, if the distance between the two consecutive particles of the medium is more than the normal distance are called refractions, and if the distance between the two consecutive particles is less than the normal distance is called as compressions. In the longitudinal waves, the compressions and refractions will be formed. If the distance is less than the normal distance is compressions. That means say if the spring is compressed. So that's why actual distance is decreases. The normal distance less than the normal distance. So that's why that is called as compressions. Whenever the consecutive particle nearer to one another. If the retractions means the particles are away from the one another for the more than the normal direction. If we are not using any force on the spring, then that will stay at the normal distance. If we use the force to expand, the normal distance will be increases. And if the oscillations, whenever the medium is in simple harmonic motion, the spring is in simple harmonic motion, then that will start oscillating, the compressions and refractions will be formed. So that's why we can say that in longitudinal waves, compressions and refractions will be formed. Once again, what is the longitudinal waves means? The direction of the propagation of a vibrating particle from its mean position is parallel to the direction of the propagation of a wave is known as longitudinal waves. In longitudinal waves, compressions and refractions will be formed. Compressions and refractions will be formed. Compressions and refractions will be formed. Refractions formed. Compressions means the distance between the two consecutive particles is less than the normal distance is called as compression. If the distance between the two consecutive particles of the medium is more than the normal distance is called rarefaction. So this is about longitudinal waves. The best example for the longitudinal waves is sound waves are the best example for that. The second one is transverse waves. Transverse waves means the direction of the propagation of vibrating particle from its mean position is perpendicular to the direction of propagation of wave is known as transverse wave. Once again, the direction of propagation of the vibrating particles from its mean position is perpendicular to the direction of the propagation of a wave is called a transverse wave. Here, in the transverse waves, crusts and troughs will be formed. Crusts and troughs will be formed. So, here is that what is crust? What is crust means? First of all, in transverse waves, the direction of the propagation of the wave is in this direction. The direction of the propagation of wave is in this direction, and the direction of the vibrating particles means in like water waves. We can see the oceans. The waves are coming to the bank. So here the waves whenever they are coming to the bank, they will move like this in a wave formation. In that the vibrating particles are moving perpendicular, means the vibrating particles are from its mean position, they are moving perpendicular to the direction of the propagation of the wave. So that's why we can say that the direction of the propagation of the vibrating particles is perpendicular. The direction of the propagation of the vibrating particles is perpendicular to the direction of the propagation of the wave is called a transverse wave. The best example for the transverse wave is water waves. So in that the transverse waves, the crusts and troughs will be formed. Crusts and troughs will be. What is crust and what is troughs? Here the crust means the maximum displacement of the vibrating particles from the mean position in the direction, in the positive direction. In the positive direction means here it is that this is the positive direction and this is the negative direction. So that's why if the waves are the vibrating particles from its mean position, if they move into the positive direction, that will be the crust, that will be the crust. And if in case the vibrating particles are maximum displacement from its mean position towards the negative direction, in the negative direction, the maximum displacement, the negative direction is called a trough. And at the same time, in this crusts and troughs will form whenever the distance between the two consecutive successive crusts and two successive troughs or two consecutive successive crust and trough is called a wavelength. Good morning all of you. Yesterday we have discussed about types of mechanical waves. Those are, first one is longitudinal wave and the second one is transverse wave. What is longitudinal wave and what is transverse wave? Already we have discussed about it in the before class. Now we are going to compare the longitudinal waves and transverse waves. First of all, what is meant by the longitudinal wave means when the direction of the particles, which is having vibrating particles from its mean position, is parallel to the direction of propagation of a wave is called as a longitudinal wave. Means when particles of the medium vibrate along the direction of the propagation of the wave is called as a longitudinal wave. And in this longitudinal wave, compressions and rarefactions will be formed in alternatively. Means when if the compression will form, then after the compression the rarefaction will be formed. Already we have discussed about the, for example, spring. Whenever spring is vibrated, then at some place the total normal distance will be less than the actual distance. After that compression, the normal distance will be more than the normal. Compression means when the normal distance is less than the other one, that is called as rarefaction. So after compression, rarefraction will be formed in the longitudinal waves. So alternatively, the rarefractions and compressions will be formed in longitudinal waves. And these waves can be formed in solids, liquids and gas, all of type of matters. The waves can be possible, longitudinal waves can be possible. And whenever the longitudinal waves are propagating in a medium, when the longitudinal waves are propagating in a medium, the pressure of the medium will be changes. Means whenever the longitudinal waves are means, then the longitudinal waves are moving through the some of the medium. For example, if the spring when the longitudinal wave, when the spring is vibrating, then the pressure between the particles of the vibrating particles will be changes. So the waves can be formed in solids, liquids and gases, as well as the pressure changes in the medium, because of they will form compressions and rarefractions. That's why the pressure will be changes in the medium when the longitudinal waves are propagating. Next one, they indirectly represents the sine wave. We know that what is sine wave? Means whenever the waves are moving like this can be called as a sine wave. When it is having that, the point will be started at the 0 point and it will go to the maximum and minimum distances. This wave can be classified as a sine wave. So indirectly, because of here the waves can be moved like this, compressions and rarefractions, like this, compressions and rarefraction. So that's why we can say that in the longitudinal waves, they indirectly represents the sine wave, and so that's why they cannot be polarized. Polarized means whenever the light is moving or sound is moving, when the waves are moving the several distances, they can be polarized, means they can be moving to the specified direction, that is called as polarizing. So these longitudinal waves cannot be polarized because of they are moving in parallel to the direction of the wave. So that's why they cannot be polarized. This is about the longitudinal wave. Means when the vibrating particles are moving in the parallel, moving in the direction of the wave, and in this rarefractions and compressions will be formed. And next one, the waves can be formed in solids, liquids and gases also. And one more thing is, the pressure changes when the longitudinal waves are propagating in a medium, their pressure changes, and as well as indirectly represents the sine wave. Indirectly represents the sine wave, and this can be polarized. This is about the longitudinal wave. If we come for the transverse wave, transverse waves means if in this longitudinal wave the vibrating particles are parallel, means in the direction of the wave, but in transverse waves the vibrating particles are right angled. The vibrating particles are right angled to the direction of the wave is called a transverse wave. In this transverse wave, crusts and troughs will be formed. Crusts and troughs will be alternatively formed. Crusts and troughs are alternatively formed in a transverse wave. These waves can be formed in mostly this type of transverse wave formed in solids and surface of the liquids. Why? Because in the surface of the liquid only the waves will be formed. We can see the oceans or lakes. Whenever the water layers are moving upon surface of the spots only, but inside the rest of water will be stays at rest. So that's why we can say that whenever the liquids are flowing, then the surface of the liquid only they will move in the transverse wave. Other remaining liquid surfaces inside the liquid they will stay at same normal rest. So that's why we can say that these waves can be formed in solids and surface of liquids. Only surface of liquids. And whenever the transverse waves are propagating in a medium, there is no pressure changes. Only whenever the longitudinal waves are propagating, only pressure changes in a medium. But transverse waves when propagating, no pressure changes. And these waves directly represents the sine wave. We have discussed about sine wave means like this. So here is that whenever the body will start, the wave will start, it is the maximum displacement of vibrating particles from its mean position in positive direction. It is called as a thruster. And whenever the maximum displacement of vibrating particles in negative direction is called a transfer. So that's why we can say that this is also directly can be represented the sine wave only. And one more thing is, whenever the sine waves are moving like this, then this can be polarized. This can be polarized. Means the wave, the direction is different because of it is moving perpendicular to the right angle. It is perpendicular to the direction of the wave. So that's why we can say that this light rays can be, these waves can be, transverse waves can be polarized in this direction. This is about okay. So now we discussed about comparison between the longitudinal and transverse waves. Now we are going to discuss about whenever the progressive wave, the displacement relation of a progressive wave. What is progressive wave? Means when a wave in which travels in a given direction with a constant amplitude, at a given direction, given position, and with respect to instant of time. At any given instant of time and position, the amplitude is constant. So that wave is called as a progressive wave. Means a wave which travels with a given direction with a constant amplitude is called a progressive wave. If in case of every progressive, in this case, every progressive wave is a periodic wave. So what is meant by the periodic wave means at any instant of time or at any instant of distance or position, the particles vibrates, amplitude is constant, is called as they repeat itself. The same constant distances is called a periodic. So here the progressive wave function represents the periodic wave. This can be the relation, the periodic traveling wave relation can be classified like this: y of x comma t is equal to a sin of kx minus omega t plus pi. This is the relation for the displacement. Here y is denoted as a displacement and with respect to position and time. X means by the position, t means by the time, and a, small a is denoted as a amplitude. Here the sine wave can be classified, and k means angular wave number. Angular wave number means the number of waves can be classified in given distance is called the angular wave number, and x is the position, and omega is denoted with as a angular frequency, and as well as pi means phase. Pi means phase. So here that y of x comma t is equal to a sin of kx minus omega t plus pi. So the wave displacement of a relation of a progressive wave is represented y of x comma t is equal to a sin of kx minus omega t plus pi. Then at any fixed instant of time t is equal to t naught, then the displacement relation will become like y of x comma t naught is equal to a sin of kx plus constant. Constant means here the time t is equal to t naught is a constant, some fixed time instant of time. So that's why the term omega t plus pi phase angle will also become the constant. And here is that the shape of the wave as a function of x is a sine function, means that will move into the like a sine direction. Next one, at any fixed position x is equal to x naught. In case of time t is equal to t naught, the omega t will be at a constant. Then remaining if the position is at constant, at any fixed position x is equal to x naught, then y of x naught t is equal to a sin of constant minus omega t. Here the position remains constant and the angular frequency and time will be stays at same as this. Then the displacement y is sinusoidally varies with the time of t. Sinusoidally varies with the time t. So that's why the function representing whenever the wave is traveling in a negative x direction, then the wave function can be displacement relation y of x comma t is equal to a sin of kx plus omega t plus pi. When the wave is traveling in a negative x direction, can be represented as y of x comma t is equal to a sin of kx plus omega t plus pi. This is the relation when the displacement of a traveling wave is in positive x direction, then y of x comma t is equal to a sin of kx minus omega t plus pi. Then in case of negative direction, the y of x comma t is equal to a sin of kx plus omega t plus pi will be the equation for the progressive wave, the displacement relation for the progressive wave. Thank you. Yesterday we have discussed about the comparison of longitudinal waves and the transverse waves. According to that, the relations also we have derived, that is displacement relation of a progressive wave. Progressive wave means whenever in a given direction, in time, the particles, the vibrating particles are continuously with the same constant amplitude, they are traveling in the specified direction. So, in case of the displacement relation, whenever the wave is traveling along the positive x-axis, then that is y of x comma t is equal to a sin of kx minus omega t plus pi. Here we know that what is y is the displacement and x is the position and t is the time and a is the amplitude, k is the angular wave number and omega is the angular frequency, pi is the phase. These are all our parameters are involved in the whenever the wave is traveling. So that's why first of all we should know that what is a. A means here a is the amplitude. Before that, whenever the positive wave is traveling along the positive x direction, we can get this equation. And if in case of the wave is traveling along the negative x direction, then y of x comma t is equal to a sin of kx plus omega t plus pi is the equation. Then the parameters which are involved in whenever the wave is traveling is the amplitude. First of all is amplitude. Amplitude means the magnitude of maximum displacement of the vibrating particles from equilibrium position. The maximum displacement of vibrating particles means whenever the wave is traveling in either positive x-axis or a negative x-axis, in whatever the direction is there, then if the wave is traveling in this direction, then the maximum displacement will be happen like this is the maximum displacement of the vibrating particles from the equilibrium position. That's why we can say that this is the equilibrium position, either thrust or drum, whatever it is. Then this is the maximum displacement of the vibrating particles, and as well as it is measured in meters or centimeters. Then it is denoted with a small a. Amplitude means the maximum displacement of the vibrating particles from its equilibrium position is called amplitude. This amplitude can be measured in longitudinal waves and transverse waves also. Whenever in longitudinal waves, compressions and rarefactions will be formed. Whenever the compressions or rarefactions will be formed, means then the mean position is that. Then whenever in rarefaction the displacement will be happened for the vibrating particle like this, then the distance, the maximum distance that can be traveled, the distance between the mean position to the maximum displacement of the particle is called as amplitude. And as well as in transverse waves, whenever the wave is traveling, the maximum displacement, whenever the wave is traveling like this, the maximum displacement which is happened, the displacement from its mean position is called as the maximum displacement from its mean position is called as amplitude. It is denoted with a and SI unit is meters. Means we can be measured amplitude in meters. Then next, another one is phase. What is phase? Phase means the state of the vibrating particle in regard to its position and time at any instant in its path of vibration. Means when the wave is traveling along some direction, then the particles are vibrating from its mean position, then the this position and time of the particle, it is sum of the time, what is the position of the particle, that will gives the phase of that particle. That is called as a here a phase means the state of the particle in regards with the position and time with respect to its path is called a phase, means the state of the particle in regard to its position and direction of motion in any instant of time. If the particle is in positive phase, means if the particle is moving like this, then this is the positive phase because of it is moving positive x-axis. If in case of wave is traveling in this direction, means it is the negative phase because of it is moving into the negative x-axis. So that's why we can say that in regard to its direction and position, and whatever the position is there, if the particle is in positive x-axis direction, then that will the space will be positive, either right theta is equal to 0 degrees, pi radians, pi by 2 radians, like that. If in case of that body is the particle is in a opposite direction, means the negative axis is, then the values also we can get the 120 degrees or 180 degrees, more than the 180 degrees when the wave is the vibrating particle position and direction will give the phase at any instant of time. Okay, then that is the phase and it is denoted with the pi. Whenever the position and time t is equal to 0, means when the vibrating particle is at rest, there is no any wave is forming. When x is equal to 0 and t is equal to 0, the phase angle will be pi. The phase angle will be pi. So that's why the phase it can be denoted with a pi. And next one is wavelength. This is the most important thing in our waves unit, because once we should know that wave, then we can get the more information about that in other topics. So that's why wavelength is the most important thing. Wavelength means the distance between the two successive points. The distance between the two successive points between the same phase, means having the same phase, means whenever the wave is in like this is the transverse wave we are taking that, then this is the amplitude, this is the maximum displacement of the vibrating particles, when this is called crest and this is called trough and this is the crest. Here the distance having the same phase, we are on discussable while having the same phase means this is the one same phase. And whenever wave is returned to its initial position, then this is also in the same phase. And we can define another way also. The distance between two successive or two consecutive, the distance between two consecutive crests or troughs, means whenever it is in the opposite direction, this is the consecutive crests. So the distance between two consecutive crests or two troughs is also denoted as a lambda. Lambda means wavelength. The distance between the two successive points having the same phase is called wavelength, and it is denoted with the lambda. Means the distance between two consecutive crests or two successive troughs, means also we can say the both are in the different direction, then the distance between the points from the initial point to another point same phase, if the total one wavelength is completed, means one completed circle or one completed wave, the time taken in a given time, if the complete the one wave is called also wavelength. The time given time, the completed wave is called as the length of the total wave is called as the wavelength. Okay, so here is that. So that is the wavelength. Next we are going to discuss the angular wave number. Angular wave number. Angular wave number means the number of waves. The number of waves in unit length are equal to one wavelength of whatever the length of the wave is travelled. The total number of waves is called as a angular wavelength. It is 2 pi times. It is a 2 pi times. So the number of waves that can be accommodated per unit length. In unit length, the given unit length, the number of waves present at that length is calculated as the angular wave number, and also this is also called as a propagation constant. It is a propagation constant k. That is also known as a propagation constant k. So that's why angular wave number can be denoted as k. Angular wave number can be denoted as a k, and as well as it is measured in a radian per meter. radian per meter, and simply we can measure it can be called as a meter. Per meter, sorry, per meter. It can be simply we can call as a per meter. And there is no zero phase of a vibrating particle. The displacement at time t is equal to 0. At taken the pi is equal to 0 means the phase of the vibrating particle is 0. The displacement at t is equal to 0. Then the displacement equation is y of x comma 0 because of t is equal to 0. Then we can get a sin kx. From this we can get the lambda wavelength. Here the wavelength means what is the distance between the two consecutive crusts or trough is called as a wavelength. So here lambda is equal to 2 pi by k because of one wavelength means the total length taken, the completed one wave is called as the length of the total completed one wave is called as wavelength. So that's why lambda is equal to 2 pi by k and k is equal to 2 pi by lambda. Wherever the k is taken to this side and lambda comes to this side, then k is equal to 2 pi by lambda. This is a angular wave number. Angular wave number can be measured as the k is equal to 2 pi by lambda means lambda total wavelength in 2 pi radians. In 2 pi radians the wavelength 2 pi radians, the number of wavelengths is called as angular wave number means the number of waves means the wavelength is the complete wave, the total length of the complete wave is called as wavelength. So k is equal to 2 pi by lambda. And next one is time period. What is time period, or it can be say period also? Time period means the time taken to complete one oscillation is called, or one wave to complete one wave is called as a time period, or the time taken by the wave to travel a distance to one wavelength. The time taken by the wave to travel to complete the one wavelength is called a time period. Means whenever the wave is traveling in this direction, then it completed. This is the one wavelength. This is the one wavelength. The time taken to complete traveled by the wave to complete one wavelength. This is the one wavelength lambda. The time taken to complete this distance is called as a time period. It's called a time period. Time period can be denoted with a capital T. Time period is denoted with a capital T, and as well as SI unit is a seconds. SI unit is a seconds. And the frequency. Next one is frequency. Frequency means the number of oscillations. The number of oscillations or the number of waves completed in 1 second. In a 1 second means at a unit time the number of waves are completed. The total number of waves completed in 1 second is called as its frequency. For example, in 1 second we can hear from the speaker sounds and another sound. How much the sound we can be heard in 1 second is called that frequency. For example, we can see the DJ boxes, speakers, home theaters. There is some watts can be measured. The edges can be placed in that box because of that much of frequency that body can be delivered. So that is called as its frequency. That means to say the number of oscillations per second denoted by nu. Denoted by nu. So nu is equal to 1 by t. And also frequency also can be defined as the thing of the reciprocal of time period. The reciprocal of time period is called as the frequency. Here the time period also we can be known as t is equal to 1 by mu also means the reciprocal of frequency also called as a time period. Here the frequency, the reciprocal of time period is also called as frequency. Here the reciprocal of frequency is also called as time period. Like this, here frequency can measure in hertz. Frequency can be measured in hertz. It is denoted by nu. These are the parameters which is involved in a wave formation, in wave equation. So if we know these values, then we can easily find what is the parameters of waves. So after frequency, we are going to discuss about angular frequency. The angular frequency means the 2 pi times the frequency of the wave. 2 pi times the frequency of the wave is called the angular frequency and is denoted with the omega. Denoted with the omega. Next, omega is equal to, we know that 2 times 2 pi by t is the formula. Then from that we can write the 2 pi nu, because we know that nu is equal to 1 by t, means the frequency is equal to, this is the relation between the angular frequency and the linear frequency. So here nu is equal to 1 by t, the reciprocal of time period is called as the frequency. So that's why omega is equal to 2 pi by t. The relation between the time period and angular frequency is t is equal to 2 pi by omega. From that omega is equal to 2 pi by t, we can write that. Then here the frequency is equal to, we know that the reciprocal of time period, we know the time period 2 pi by omega, the relation between the time period and angular frequency is 2 pi by omega. So the 2 pi omega is equal to, we can write in the equation, then we can get omega by 2 pi, means nu is equal to 1 by omega by 2 pi, that is equal to, 2 pi by omega, that is equal to omega by 2 pi. This is the equation for the frequency relation between the angular frequency and a linear frequency. From that we can write that omega is equal to 2 pi nu. 2 pi nu. This is the relation, and also we can write that here the relation between the angular wave, remember relation between the velocity and angular velocity and the angular frequency, omega is equal to, we have the formula also, v is equal to omega by k, and as well as that is equal to, we can write that here from this equation also we can find out that omega is equal to, here k is equal to omega by v, but we know that omega is equal to, we have the formula 2 pi nu, means 2 pi by t, so 2 pi by t, and again from the velocity equation we can write that t by lambda. Here we can get the t by lambda from the equation, t is equal to, we know that nu lambda, nu from the equation v is equal to nu lambda, nu is equal to reciprocal of time period from the equation lambda by t. So from this relation we can write that v is equal to lambda by t, that from the relation we can write that t by lambda. So here we should know that, we should remember this formula. So 2 pi by t and t will be cancelled. From the k is equal to, angular wave number k is equal to 2 pi by lambda can be derived from the equation also. This is about the parameters which is involved in when the wave is traveling. Thank you. Tomorrow we will continue that. Next, in the next video we can discuss about that sound waves. Thank you. Hello everyone. Today we are going to discuss about sound waves. Sound waves means a sound is a form of energy which creates the sensation of hearing to human ears. Sound is a form of energy which creates the sensation to hearing to the human ears. That is the sound wave. Here, when we clap, then our hands, means our muscle energy can create the sound. The sensation can be heard by the human ears. Means the muscle energy is converted into the sound. So that's why here we can say that sound waves can be created sensation to the human ear. That only we can hear the sound. Then here sound waves are longitudinal waves. Means whenever the sound waves are propagating through the medium, then compressions and rarefactions will be formed. Compressions and rarefactions will be formed. Due to that, we can hear the sensation. Then the frequency range of sounds, between 20 Hz to 20,000 Hz or 20 Hz to 20 kHz. 20 Hz to 20,000 Hz or 20 Hz to 20 kHz sounds or the frequency range is called as the audible range. 20,000 Hz to 20,000 Hz frequency range of sounds can be called as a audible range, and less than the 20 Hz sounds, frequency range of 20 Hz, less than the 20 Hz range is called as a infrasonic range. infrasonic range, and more than the 20,000 Hz. More than the 20 means greater than the 20,000 Hz sounds or frequency range is called as a ultrasonic range. Frequency range is called as a ultrasonic range. So these infrasonic and ultrasonic sounds cannot be heard by the human ear because of the audible range is only for 20 Hz to 20,000 Hz only. Below the less than the 20 Hz, greater than the 20,000 Hz, that sounds, the frequency range cannot hear by the sense by the human ear. So that's why infrasonic and ultrasonics are not here sensible to the human ear. That is not audible sounds. Only 20,000 Hz below the less than the 20,000 and below the greater than the 20 Hz sounds can be heard by the human ear. That is called as audible sounds. In this case, the velocity of the sound, in air at room temperature and on normal pressure, at room temperature and pressure, at room temperature and normal pressure is 332 meter per second, 332 meter per second, which is 1200 kilometer per hour, 1200 kilometer per hour. The objects which are moving more than greater than the speed of a sound, the objects which is traveling more than the greater than the speed of sound are called as a supersonic objects. Supersonic speed, the speed is called as a supersonic speeds. And one more thing is, sound waves cannot propagate or cannot travel without any medium. Without medium, sound waves cannot propagate. These are the sound is a form of energy which creates the sensation to human ears, to hearing sensation. Then sound waves are longitudinal waves, and below between the 20 Hz to 20,000 Hz frequency range sounds can be heard by the human ear. Less than the 20 Hz sounds are called as the infrasonic sounds, and greater than the 20,000 Hz sounds are called as the ultrasonic sounds. The velocity of the sound in air at room temperature and pressure is 332 meter per second, in which 1200 kilometer per hour. And the objects which are traveling more than the means greater than the speed of sound are called supersonic speed. That speed is called supersonic speed. Without any medium, sound cannot propagate or cannot travel. This is about sound waves. So, speed of a traveling wave. Just now we have discussed about the sound wave. Whenever the sound is traveling, means when a progressive wave, when the wave is in progression, then a wave is moving in positive x direction. Wave moving in a positive x direction. At two instants we have taken that when at a time the small interval of time wave is the instants are a progression wave, from time t to t plus delta t is the small interval of time. Then its position displacement can be transferred, means the speed of traveling can be observed by observing the crests of the progressive wave. Crests of the progressive wave. When the wave is traveling along the positive x direction, means when the wave is traveling positive x direction, by observing the crests we can derive the velocity or speed of a traveling wave. Then the progression wave from the time to wave taken the two instants of time. The first wave at the time t, and after some time is small, there is a small interval of time is there, t plus delta t. So that's why we are taking the progressive wave time t to t plus delta t. That is small interval of time. Small interval of time is delta t. And there is a small displacement at the same pace. There is a small displacement which is having the delta x. First wave projection, first at a time t, the displacement of the wave is x, and after some distance means that the second instant of time the displacement of the wave will be the small change in displacement, that is delta x. So that's why we can write that then x plus x2 x plus delta x be the change in displacement. So that's why we can write that here the progressive wave time has taken the 2 instants of time, that the small change in interval of time, then its displacement is having the same phase, means here phase is the constant, so that's why we can write that the velocity can be written as the velocity or speed. The speed or velocity can be written as v is equal to delta x by delta t. We know that delta x by delta t means the rate of change of displacement is called as the velocity. So that's why we are writing that here the rate of change of displacement is called as velocity. V is equal to delta x by delta t. Here is that the total value changes to that t changes to t plus delta t, and as well as the displacement changes to x plus delta x plus delta x. Here is that we know that value is that at any point wave will move with the same speed, because when the 2 instants of time has taken in a small interval of time, when the time t the displacement of the crust, the point, the particle is in this position, and after the t plus delta t a small interval of time taken, the change in time of interval, the position displacement is also changes. So that's why we can write that a small interval of time changes g plus delta t, execute the x plus delta x with the position, then kx minus omega t is equal to constant. Kx minus omega t is equal to constant. Here is that when t changes, if time changes, then x also changes, because of the position of the particle also changes with the respective time. So that's why here the same phase, but the phase remains constant. So x also changes, must be phase at constant, phase at constant. So that's why we have written that kx minus omega t is equal to constant. Kx minus omega t is equal to constant. We can write that. So that's why we are substituting these equations in the above equation. Then we can get kx minus omega t is equal to, in this position x changes to x plus delta x and t changes to t plus delta t, because of we are making the 2 instants of time. So that's why from the initial wave is at time t, the small instant of time changes, then position displacement is also changes to x plus delta x. So that's why k of x plus delta x minus omega of t plus delta t. By the calculation we can write that kx plus k into delta x minus omega t minus omega into delta t. So from this equation we can write that kx minus omega t is equal to this kx will be cancelled, and minus omega t will also cancel. From this equation remaining factors are k dot delta x minus omega into delta t. So that's why we are writing that k into delta x minus omega into delta t is equal to 0. From this equation we can write that delta x by here delta x and delta v is vanishingly very small. Delta x comma delta t are small. Delta x and delta t are very small. So that's why we are writing that here the delta x and delta t becomes delta x by delta t is equal to, we can write that omega by k. But we know that delta x by delta t means the rate of change of displacement. So that's why we are writing that here the omega by k is equal to v. Omega by k is equal to v. From this equation omega by k is equal to v, we can write that. But we know that from the angular frequency and angular wave number, omega is equal to 2 pi mu, and as well as k is equal to 2 pi by lambda. We are substituting these two equations in the v is equal to omega by k, then we can get v is equal to omega is equal to 2 pi mu and k is equal to 2 pi by lambda. The 2 pi will be cancelled. The lambda is the denominator for denominator. So that's why lambda becomes numerator. V is equal to nu into lambda. This is the universal equation for general equation for progressive waves. We can write that V is equal to nu lambda be the general equation for progressive waves. That is the speed of a traveling wave. Once again, when the wave is taking with a small instance of time, the displacement is also changes, but in the they are having the same pace. So that's why the displacement of the crust here, the delta x, with the small interval of time is the delta t. So that's why at the first wave is at the t time, and second wave small change in delta t. So that's why t plus delta t be the small change in interval of time. So that's why progression time changes to t to delta t plus delta t, and as well as its position x changes to x plus delta x. So, but we know that the wave is moving with constant speed at any point. So that's why v is equal to delta x by delta t, means velocity is equal to the rate of change of displacement, or the rate of change of position is called v is equal to delta x by delta t. So that's why at any point wave will move with same speed. So that's why it stays. The time changes, then its position also changes. So that's why the phase remains constant. Phase remains constant. So that's why here kx is minus omega t is equal to constant. Then kx minus omega t is equal to x changes to the x position changes to x plus delta x. So that's why k of x plus delta x minus omega of t plus delta t. Means t changes to t plus delta t, initial wave and second instant of wave. Then if we multiply it inside, then we can get kx minus omega t is equal to kx plus k dot delta x minus omega t minus omega into delta t. Then k dot delta, the remaining factors after cancellation. The remaining factors are k dot delta x minus omega dot delta t is equal to 0. Then delta x and delta t, in this factor the delta x and delta t is the small interval of time and small interval of changes this position in position. So that's it, they are vanishingly very small. So that's why we are writing that delta x by delta t. Here delta x by delta t is equal to omega by k, but we know that delta x by delta t is equal to the rate of change of displacement. So we are writing that delta x by delta t is equal to omega by k, that is equal to v, and so that's why we are writing that here the value omega is equal to, we know that omega is equal to 2 pi nu, and as well as k is equal to 2 pi by lambda. From the omega is angular frequency and k is the angular wave number. Before we have discussed in the before videos. So omega is equal to 2 pi nu and k is equal to 2 pi lambda. If we substitute the equation in the above equation omega by k, then we can get v is equal to nu lambda. So from the v is equal to nu lambda is the general principle for progressive waves, As well as we can write that we know that mu is equal to 1 by 10, means the reciprocal of time period. From the time we can write that lambda by t. Then from this also lambda is equal to t into t also we can write that. Here the wavelength of the wave is depends on its velocity and its time period. This is about the speed of a traveling wave. Here we should not forget about v is equal to nu lambda. This is the most important thing formula. In further topics we will use that formula. V is equal to nu lambda. This is the important. V is equal to nu lambda. We will use the formula in when the medium is at A, or likewise when the medium is at A or vacuum. Clear? If is there any medium is there like a string or another medium is there, then we will use the density and also linear density and mass density also taken. So that's why this is the equation for the all general progressive waves. Equation for the progressive waves for all wherever is taken in air or vacuum. General equation for progressive waves. Thank you. Hello everyone. In before video, we have discussed about the speed of a wave in air or vacuum. Now we are going to discuss about the speed of transverse wave in a stretched string. Stretched string means we have already found out that we have derived the equation v is equal to nu lambda, the general equation for the progressive wave earlier. Now the speed of a transverse wave, if in case of the medium is not a air or vacuum, whatever it is, if it is another medium, means like a stretched string or the material medium. If the medium is material, then what is the speed of a waves? We are going to derive a equation. When the speed is expected to that directly proportional to the restoring force. Whenever if we take in the medium and then vibrate it, then it will start, the waves will be formed in the sound waves are formed in the medium. Then whenever the restoring force will happen, and also the inertial property is also there in the material medium. So that's why we are taking that the speed expected to be there. Then directly proportional to the restoring force. Directly proportional to the restoring force means that body material medium, how it is having that restoring, how the force is applied, then how much that can be restored is force. That is directly proportional to the restoring force and inversely proportional to the inertial property. That body is having some inertia, that inertial property, the speed also depends on its inertial property, and as well as the restoring force that body can, the material medium can apply. So that's why we are taking that we can expect the velocity or speed of a wave in a stretched string. It depends on the material medium, its inertial property, and as well as the restoring force which can body can be applied. So from the by using the dimensional analysis, we can measure the equation, we can derive the equation for a stretched string. If we take the stretched string, it is having the restoring force provided by that. Whenever we use the force on the body, it will get started oscillating, or the waves are formed in the string. Then the tension will be happened in the string. The tension will give the value for restoring force. The tension is the restoring force, and as well as the inertial property means the mass, linear mass density. The mass density will be the linear mass density will be the inertial property of the stretched string. The inertial property of the stretched string of the per unit length means mass per unit length is called as a P mass density. Mu is equal to m by l. You know that mu is equal to m by l. That is the mass density of the string. By using the dimensional analysis of mu means mass density and as well as the tension, that much tension is applied in the string. That is the formula can be derived by using the dimensional analysis of the tension and its mass density. The dimensional formula of mu means mass density is equal to m L power minus 1, L inverse, m L inverse, and the dimensional formula of tension is m L. If is there nothing, then m power 1, L power 1, T power minus 2. By using this dimensional analysis to know the formula for the speed, we should combine this formula mu and T. So the dimension of the speed is L T inverse. So that's because of meter per second. Meter per second means meter is the length, and per second means T power minus 1. That is the dimensional formula of speed. So on analysis, the T by mu has the relevant dimensions of the speed. The T by mu has the relevant dimensions of the speed. So that's why T by mu is equal to m L T power minus 2 by m L power minus 1. Then here the mm will cancel. Then whenever the denominator L power minus 2 take it to the numerator, then it will become L power 1, that will become L power 2 and T power minus 2. That is T by mu is equal to L into T power minus 1. We can write that whole square. So whenever square taken to this side, then L power T minus 1 is equal to root T by mu. That's why whenever the material medium is there, then the velocity of the L into T power minus 1 dimensional formula is for speed, that is v. So that's why we are writing that v is equal to root T by nu, root T by nu. If we take the sound waves or the speed of transverse waves in a stretched string or any material medium which is having the tension can be developed in the medium, and also it is having the inertial property. If the material medium present the wave is traveling through the material medium, then we should apply this formula to find out the values. Then we should use this formula V is equal to root T by mu. Here V is equal to root T by mu. Here stretched string already we have derived, that is V is equal to root T by mu. As well as by using the dimensional analysis, we can find the value for the speed of a transverse waves in solid also, that is V is equal to neta by rho. Neta by rho. Here neta is equal to rigidity modulus, and at the same time rho is equal to density of the material of the solid. So V is equal to neta by rho is the value, is the formula for the speed of a transverse wave in a solid. We are going to see a problem on V is equal to root T by mu. A steel wire 0.72 meter long has a mass of 5.0 into 10 to the power of 3 kg. If the wire is under a tension of 16 Newton, what is the speed of transverse waves in the wire? Means here given that the steel wire has a length of 0.72 meters and its mass is 5.0 into 10 to the power of minus 3 kg, and 16 newtons of tension is applied on the steel wire. 16 newtons of tension is applied on the steel wire. So that's why 0.72 meter long has a mass of 5.0 into 10 to the power of 3 kg is the mass. So the length of the steel wire is L is equal to 0.72 meter. As well as mass of the steel wire is M is equal to 5.0 into 10 to the power minus 3. Mass is M. Then tension T can be denoted with T is equal to 16 newtons of force is applied. Tension is applied on the wire. Then we know that the mass density V is equal to actual formula is V is equal to root T by mu. Mu is the layered mass density. So that's why from the mass density, mass per unit length of the wire is M is equal to mu is equal to M by L. You know the M value is 5.0 into 10 to the power of minus 3 by length of the wire is 0.72 meter. Here is the SI unit is there. So that's why both are in SI unit. So that's why we are taking directly the values. If in case of the values is given in a CGS system, we should convert the CGS values into the MKS system, means SI unit system. Then by the calculation we can get the value 6.9 into 10 to the power of minus 3 kilogram per meter. Then we have the formula for speed in a stretched string, that is V is equal to root T by mu. T is equal to 60 units and mu is equal to 6.9 into 10 to the power of 3. By the calculation we get the 93 meter per second. This is the also for the this much of velocity will be happened. 93 meter per second value will be the speed of the transverse waves in the wire. Then as well as the longitudinal, the speed of a longitudinal wave in a medium, we taken that by using the bulk modulus. If in case of bulk modulus, which changes the pressure. That means to say longitudinal waves. Whenever the longitudinal waves are propagating in a medium, the pressure will be changes. So that's why the density is also changes. So that's why we are writing that speed of a longitudinal wave V is equal to, which is equal to bulk modulus, that is delta P by minus delta V which is compressive. Which is a compressive bulk modulus, which is a compressive. So that's why negative symbol indicates that the compression force. From that velocity V is equal by using the same as equal to pressure. Pressure is nothing but P dimensional formula we can get. From that equation V is equal to C. C be the constant. Then here the root of d by rho is the formula for speed of a bulk modulus of longitudinal wave in a wire. Then if in case of longitudinal wave in solid, in solid V is equal to root of pi by rho. Root of pi by rho. Y denotes the Young's modulus of value. Young's modulus. Then rho is the, we know that rho is the value for density of the material. Whatever the density of the material. Y is the Young's modulus. Y is the Young's modulus and rho is the density. Rho is the density of the material. Hello everyone. In before part 5, we have discussed about the speed of a transverse wave in wave and also the speed of a longitudinal wave and the speed of a waves in a string. We have discussed about that v is equal to nu lambda and as well as whenever the waves are traveling through a string, then v is equal to root t by mu is the speed equation we have derived. Now Newton has given the first formula for waves in gases, means Newton's formula for speed in gases, the first formula given by the Newton. So that's why we are taking that for an ideal gas he has taken that. From the ideal gas we know the equation for ideal gas equation, that is PV is equal to nRT. Here the PVE is equal to NKVT. Newton assumed that when the sound is propagating in gases, then that will be the isothermal process. The temperature remains always at constant. But so he has taken that from the bulk modulus of elasticity, the pressure is also takes place. Whenever the pressure is applying, the temperature is exchanging from the surrounding, so that's why the temperature is always remains constant. He assumed that thing, so that's why he got the equation for the P is equal to root of P by rho. This is the first relation, so that's why I taking that this is Newton's formula. But small error is there. According to the equation, Newton's formula of equation, then we can't get the actual speed. The experimental method was not getting the result from that formula. So that's why according to that experimental formula, experimental value of the speed is 331 meter per second. But according to Newton's formula, we have taken that the theoretical value is 280 meter per second. This is some of the flaw is there, the error is there. So according to this formula is not to be used to find the speed of a waves in gases. So that's why speed of a sound in gases. So the percentage error is 15% due to the experiment, between the experimental value to the theoretical value. Some error is there, that is the 15% of error, that is 51 meter per second value is there. So again the mathematician Laplace has corrected this error because he assumed that Newton assumed that the process is a isothermal process. He did not accept that the process is not a isothermal process, but the process when the sound is traveling through the waves, means gases, in the adiabatic process. That is not isothermal process, but it's isothermal process. Because of that, that's not isothermal process, it's a adiabatic process. In that adiabatic process, the temperature does not remain constant because of the time speed for the wave is very fast. In that small interval of time, the heat cannot be exchanged from its surroundings. So that's why the temperature changes. So that's why that process is a temperature. The process is a adiabatic process. According to the ideal gas equation, the condition is satisfied the ideal condition. So that's why from the adiabatic concept, P into V power gamma is equal to constant relation. If we differentiate on both sides, that P into gamma, if we according to the mathematical formula d by dt of uv formula, if we differentiate this one, then we can get P into V power gamma means for x from the formula of n into x power n minus 1 means d by dx of x power n is equal to n into x power n minus 1 formula. From this formula we can give the equation that P into V power gamma is equal to P into gamma into V power gamma minus 1 into delta V. And as well as when the formula is derived, when the formula is correct derived, again u into v dash plus v into dvu by dt form, according to the basic one. Based on that one, then we can derive the equation for that. Then v power gamma into delta v is equal to 0. V power gamma into delta v is equal to 0. From that relation, we can get the value for the delta p. We should derive that equation. Then we can get the value Then whenever the delta p equation taken to that side, then p into gamma b power gamma minus 1 delta b, that is equal to minus b power gamma delta p, b power gamma delta p. Then if we take this delta p also in that side, it will become the denominator. It will become the denominator. So that's why gamma p is equal to minus b power gamma delta p by b power gamma minus 1, b power gamma minus 1 into delta v, b power gamma minus 1 into delta v. From this relation we can write that this one, the b power gamma is taken to the outwards, because of this we can get b power minus gamma. Then bases are equal, power should be added. Then minus delta p by b power gamma minus gamma to b power gamma minus 1. So from this relation we can get, we should add it, then it will get to delta v. Then power bases are equal, so power should be added. From the relation we can get minus delta p. So from the equation delta p is equal to minus b power gamma into delta p and by b power gamma minus 1 into delta v, then we can write that the total value gamma p is equal to minus delta p by whenever the b power gamma is taken to denominator, then it becomes b power minus gamma, b power minus gamma, b power minus gamma into b power gamma minus 1 into delta v. From this relation we can get minus delta p by bases are equal, so power should be added. So then we can get b power minus gamma plus gamma minus 1 minus gamma plus gamma can cancel, then delta v. From this b power minus 1, b power minus 1, then if this b power minus 1 can be write like this, then delta p by minus delta v by b power minus 1 can be written as a denominator for denominator, the delta v. So that's why we can get that. From we know that from the bulk modulus, when the speed of through the liquids, when the bulk modulus of velocity v is equal to minus delta v by delta v. So that's why we can write that delta v which is equal to b. From this relation we can write that v is equal to root of b by rho is the equation. Then from this equation we can write that root of gamma p by rho with the from the Laplace correction. From the Laplace correction we can write that the speed of a wave in gases we can write the root of gamma p by rho. Gamma p by rho. We know that gamma is equal to Cp by Cv, means Cp by Cv. This is the specific gravity constant, specific heat constant. We can write the specific heat constant gamma is equal to the ratio of specific heats at constant pressure and constant volume. We can write that the ratio for air. If we take the gamma value for air, the gamma is equal to 7 by 5. If we substitute these values in the equation, then we can get finally, then we can get that the experimental value, that is 331 meter per second. This is about Laplace correction, which is having the Newton's formula is having error. So to correct that error, Laplace has assumed that Newton's formula is, according to the Newton's formula, the propagation in gases of a sound is not a isothermal process. The assumption is wrong, but according to the Laplace correction, the propagation of a sound in gases is a isothermal process because of the forwarding, means the propagation, the sound speed of a sound is very fast. In that small interval of time, the heat cannot be, the temperature cannot be exchanged to its surroundings. So that's why temperature can't be constant. That is the assumption by the clarification, by the correction of the Laplace. We can get the equation, that is v is equal to root of gamma p by rho. That is equal to, we can get that by the calculation, that is v is equal to gamma p by rho is equal to 331 meter per second is the value for speed of a sound. So according to the Laplace correction, the correction of Newton's formula. Correction of Newton's formula is a Laplace correction. The speed of a sound is v is equal to root gamma p by rho with the equation for Laplace correction. Speed the value for we can get the experimental value. Then the correction of Newton's formula is the Laplace correction. The next we are going to discuss about the principle of superposition of waves. What is meant by the principle of superposition of waves means? Here the principle of superposition of waves means whenever two or more waves simultaneously meet at any point at a given time, at some time, at any instant, two or more waves are meet simultaneously in a medium. The net displacement of the waves, the net displacement at a given time is equal to the algebraic sum of the displacements due to each time, the displacement due to the each wave of that time. Means the total net displacement which is equal to the algebraic sum of the individual displacements of the waves which is traveling in a medium is called the principle of superposition. Here the y is taken as the net displacement and the y1 is the individual displacements which are traveling in a medium, that is y1 by 2 so on to yn. If the number of waves are present in the medium, two or more waves, we answer that two or more waves meet simultaneously at a point, then we can write the equation. Means, for example, here we are taking that when the wave is traveling like this and in same string, then opposite direction another wave is traveling in this direction. If the time t is equal to 0, the starting stage two waves. Each and every wave will travel to the medium is that no others present in the medium. No other waves are present in the medium. They behave like that. No, there is no any other wave present in the medium. Only that wave is traveling to the medium. Like that, then a wave is traveling through this direction. Then another opposite pulse wave means pulse another wave is traveling in this direction. Then after some time, there will be the displacements will be they both cancel with each other because they are having the same amplitude and same frequency, same direction. So in the opposite direction. So that's why they will be cancelled to each other. Then finally they will come to like this. So here whenever they are moving in opposite direction, they will the change in phase. If the both are change in phase, then we can get this equation. If we want to find out the principle for superposition of waves for mathematically, for example, if the y1 with the one wave is equal to f1 of x minus vt with the wave equation for the first wave, and y2 with the f2 of x minus vt with the second wave equation. Then according to the principle of waves, y is equal to y1 plus y2. Then from that equation, y is equal to y1 plus y2, that is equal to f1 of x minus vt plus f2 of x minus vt. From this relation we can get for n number of waves also we can write that y of n is equal to, with respect to its position and time is equal to, we can write that similarly I is equal to 1 to n f of I of x minus vt with this is the mathematical equation for the superposition of waves. Means whenever the first wave equation is y1 is equal to f1 of x minus vt and y2 is equal to f2 of x minus vt with the second equation. From the relation, from the principle of superposition of waves, we know that the net displacement of the waves, the displacement of the waves in a medium which is equal to the algebraic sum of the wave displacements of the wave, individual waves in the is called the principle of superposition of waves. From that formula we can write that y is equal to sigma I2 y is equal to 1 to n fy of x minus vt with the principle of superposition of waves formula. Once again, the definition of principle of superposition of waves is two or more waves meet simultaneously in a medium. Two or more waves meet simultaneously at a point in a medium. The net displacement at a given time. The net displacement at a given time is the algebraic sum of the displacements. Algebraic sum of the displacements due to each wave at that time. when the time the total waves meet simultaneously at a point, at that point, at that time, the algebraic sum of the displacements due to each wave is called the principle of superposition of waves. This principle of superposition of waves is the basic to the phenomenon of interference. Interference means whenever two waves are simultaneously meet, it depends on one another, collapse on one another. That is called as interference. When the waves traveling in a medium, they will travel like this. One wave is moving in this direction. It will behave like the thing that it will behave like A. There is no another wave is traveling in the medium. Then also another opposite will change, different change pace in the opposite direction. When they meet at a point. When they meet at a point, two waves meet at a point, they cancel each other, then the final displacement becomes y is equal to 0. Because of there is no any y1 displacement, there is no any y2 displacement. So that's why the net displacement made at a point is a 0. Like this. If in case of both waves are traveling in the same direction, both waves are in the same direction but small phase difference is there, then we can get the equation for that like this. Hello everyone. This is the continuation for part 6. Principle of superposition of waves. When consider two waves of same amplitude, same angular wave number, and they are having the same angular frequency and their speeds also identical. Means consider two waves, two sound waves of same angular frequency and angular wave number, and their speeds also identical. The speeds also identical, and as well as only they both traveling in a same medium. Only they differ to each other in its initial phase. Differ in its initial phase. Differ in its initial phase. Initial phase 5 means if we take that waves, one wave is traveling, its phase is pi is equal to 0, and another wave if we take that, it is making pi is equal to pi radians. Differ with the pi radians means if the wave is traveling like this and they differ with the pi radians with the initial wave, then what will happen? Let's see. First of all, the equation y of first wave equation y is equal to a sin of kx minus omega t. This is the first wave equation, and the second one is y2 is equal to a sin of kx minus omega t. This is having that phase change, different phase. Both waves are having the same identical, same angular number, same angular frequency, same position, same amplitude also. Traveling in a medium, only they differ with the initial phase. It is having that kx minus omega t, the initial phase pi is equal to 0, we are not getting pi. But in case of it is I am having that some pi phase difference with the first one. So then we can get that from principle of superposition of waves. From superposition of waves, then we can get y is equal to y1 plus y2 means the net displacement which is equal to or 4 waves are traveling in a medium. The net displacement of the total waves is equal to the algebraic sum of the individual waves. The algebraic sum of the displacements of the individual wave at that instant of time is called superposition of waves. From that equation we can get the resultant y is equal to resultant displacement, net displacement y is equal to, we are substituting this one, a sin of kx minus omega t plus a sin of kx minus omega t plus phi. From the mathematical form, sin A plus sin D. This is similar to the formula which is having that sin A plus sin B is equal to 2 sin A plus B by 2 cos A minus B by 2. This is the mathematical formula. You should remember this one. This is the mathematical formula sin A plus B. Sin A plus sin B is equal to 2 sin A plus B by 2 cos A minus B by 2 is the mathematical formula of this one. This one is the similar to this formula. A is taken outside common because of in these two factors the A is same, so that's why we are taking outside. Then we can get sin A plus B by 2, 2 side A plus B by 2 means y is equal to 2, A is taking outside, then we can get sin A plus B by 2. Sin A means kx minus omega t by sin A plus B means kx minus omega t plus pi by 2. Okay, then next cos A minus B by 2, A minus B by 2, A kx minus omega t minus kx plus omega t minus pi. I am multiplying minus negative sign into that one, then we can get by 2. Minus kx plus kx get cancelled, minus omega t plus omega t get cancelled, we can get only the minus pi by 2. Minus pi by 2. So y is equal to here kx minus omega t plus kx minus omega t. 2 of kx minus omega t we can write that 2a sin 2 into kx minus omega t plus pi whole by 2 cos minus pi by 2. Here the minus symbol indicates that is differ the 180 degrees with the initial one. 180 degrees with the initial one. So that's why we are writing that here cos of minus pi by 2. Here 2a sin of 2 kx minus omega t plus pi by 2. If we the denominator individually, if we write the individually, then we can get 2a sin of kx minus omega t plus pi by 2. Here cos minus pi by 2 minus cos pi by 2. Here just listen, y is equal to 2a sin of 2a sin 2 of kx minus omega t plus pi by 2. The denominator 2 is separated, so that from that equation we can get that the minus value will given that is for it is differ to the negative pair, so that's why we are neglecting that one. Y is equal to 2a cos pi by 2. I am taking from side, then sin of kx minus omega t plus pi by 2. Here the pi by 2 is the phase difference between them. The pi by 2 is the phase difference between them. Then the amplitude, the net result amplitude is also here the initial phase angle is pi by 2, and also this equation also represents a harmonic traveling wave. A equation also represents a harmonic traveling wave in along the positive x direction. Positive x direction. A harmonic wave is also this equation represents the harmonic wave is traveling in the harmonic traveling in the along the x direction. Then the initial phase angle pi by 2. The initial phase angle is pi by 2. The initial phase angle is pi by 2. The amplitude a of pi is the phase difference. We can write that this here is the amplitude. Compare this equation with the resultant equation. We can get that a pi. A of pi means due to the phase difference, the amplitude will be is equal to 2a cos pi by 2. 2a cos pi by 2. If in case of in this equation, if we substitute the phase angle, means if in case of case 1, if pi is equal to 0, means if it becomes 0, then what will the total equation? Cos 0 will become cos 0 is 1. So again sin is the pi by 2 is 0. Sin of kx minus omega t means y is equal to a sin of kx minus omega t. Kx minus omega t. As well as if in case of pi is equal to phase difference. If we substitute that phase difference, pi is equal to 180 degrees, then we can get the negative value. Means here the cos pi is equal to the cos 0 is equal to 1, as well as here the cos 180 degrees is also minus 1, and here also sin 180 is equal to sin 180 is also 0 1. Sin will the minus value. If in case of pi by 2 means 90 degrees, then what will happen? Total term becomes this total term becomes the net displacement y is equal to 0, because of if in case of 90 degrees the both will be cancelled to each other. So this is about the mathematical form we can explain whenever the two waves are superimposed on one another, means if they meet it simultaneously by equation. This equation represents the harmonic traveling in a medium along the positive x direction, and if the phase angle depends on that, then the equation that displacement will be depends on the phase angle also. So reflection of waves. Reflection of waves means here when wave travels through the medium and meets the rigid boundary, it gets reflected. For example, whenever we are make the noise in a hall between the rigid boundaries, then we can hear the sound repeatedly, that is echo. Echo is the best example for the reflection of waves. So here when sound wave meets the rigid boundary, it gets reflected. For example, echo. And if the boundary is not a fully rigidly bound, or it a interface between the two medium, then the sound, when the sound wave is incident like the surface, then a part is reflected and the remaining part is transmitted through that and they meet to the second medium, they are traveling to the second medium. Means if the rigid boundary is not fully rigid and it is an interface between the two surfaces, two media, a part is reflected and it is another part is transmitted to the second medium. When the boundary is not fully rigid, if the wave is obliquely incident on the rigid boundary, means when the wave is obliquely incident on the rigid boundary, and there is a reflected wave which is having the same amplitude and same speed without changing the how much the incident pulse is there, that much of amount of amplitude and speed also there, but they differs in the phase angle. Phase angle which is having that it's a 180 degrees or a pi radians of phase angle will be differs. Only phase angle will be different. Remain the amplitude and wave frequency will be the same when the wave is incident on the rigid boundary obliquely, then only that will happen. If the boundary is not fully rigid, when the wave is transmitted to the another second medium, that wave is called a refracted wave. If the wave is incident on the rigid boundary, it will comes back means reflected, that wave is called as reflected wave. If in case the rigid boundary is not fully rigid, it's a interface between the two media, then when the sound wave meets incident on the interface media, then the wave will be when the incident on obliquely, then the transmit to the other medium, that is the refracted wave. If the rigid boundary, if the sound wave is incident on the obliquely incident on the rigid boundary, then that will return which the incident wave is having the same parameters, that much of parameters also having the by the refracted wave. But the small change is that when the phase will be, it is 180 degrees or pi radians. The differ with the incident wave, the refracted wave is differ with the incident wave is only phase change in phase. Its phase is 180 degrees or pi radians. This is according to the superposition of waves. This is possible according to the superposition of waves. because here the boundary is a rigid, no disturbance and no energy absorbed by the wall. There is no any displacement of the rigid boundary. So that's why the same amount of angle, the same amount of energy returns to the reflected wave. It will happen. That condition is called as a boundary condition. That condition is called as a boundary condition. By the principle of superposition of waves, the incident wave and the reflected wave differs with the phase angle of phi. With the phase angle of phi, so that the displacement of the wall is 0. This condition is called boundary condition. Means here when the incident wave and reflected wave have phase angle, differ with phase angle. Phase angle is phi radians. Displacement of boundary, displacement of rigid boundary, displacement of rigid boundary is 0. This is called, it is called boundary condition. Boundary condition. It is called a boundary condition. Thank you. Hello everyone. Today we are going to discuss about the formation of a standing or stationary waves in a stretched string. That means when a string is stretched between the two rigid supports, if that string is vibrated, then some loops are formed. Means when a two progressive waves are having same amplitude, wavelength and frequency and traveling with same speed, but along the same straight line but in opposite directions, some new set of waves form. That waves is called as standing or stationary waves. Means when two sets of progressive waves are with the same amplitude, wavelength, frequency, time period and moving with same speed or traveling with same speed but in opposite directions, a new set of waves will be formed. That waves is called as standing or stationary waves. In that case, when here is the one wave is traveling like this in this direction, in the positive x direction, and another reflected wave is also moving in this direction to the opposite to the incident wave. Opposite to the incident wave. Two sets of progressive waves are in moving with same amplitude, same wavelength, same frequency, same time period, and but in opposite direction. Means one wave is traveling in this direction and another wave is moving in this direction. So that's why here the new set of waves are formed. This waves is called as standing or stationary waves. In this case, the loops are formed between the two rigid supports when the string is vibrating. If the vibrating particles of the string, means there is no any energy is transferred from one place to the another place, but the vibrating particles are vibrating from its initial position to its mean position to the simple, it will be in a simple harmonic motion. So that's why here the when maximum displacement of vibrating particles, if the resultant displacement of vibrating particles is maximum, is known as antinode. Antinode. When the maximum displacement of the vibrating particles is called antinode. If in case of the displacement or the resultant displacement of vibrating particles are 0, that is called nodes. Here once again, when the resultant displacement of the vibrating particles is 0 or minimum is node, and the resultant displacement of the vibrating particles are maximum is called a antinode. Here the nodes and antinodes were already denoted. This one, this position is the node position and this position is the antinode position. So whenever node, antinode, node, antinode, node, antinode, whenever the consecutive, the distance between the consecutive antinode to node is a lambda by 2, that is called as half wavelength. Then if in case of two successive nodes having the same phase or two successive antinodes in the same phase is called a wavelength. The two successive nodes are two successive antinode means here is that this one is the one successive antinode and another one is this is the another successive antinode which is having in same phase, but this particle is in opposite in direction, so that's why we can't measure this one. If in case of here is the one node position and another one is here is the another node position, because of the vibrating particles are in this direction. But in case of in this place, the vibrating particles are in this direction, so opposite in phase. We are saying that whenever they are in the same phase, then that will be called as a wavelength. Here is when wavelength is equal to the time period. So here the what is node and what is the antinode position, what is the distance, what is the determination of nodes and antinodes position is. We can classify into the this one. Here is that once again the stationary or standing waves means when two sets of waves of same amplitude, frequency, wavelength and traveling with same speed along the straight line in opposite directions superimpose a new set of waves formed. That waves is called as standing waves when the maximum displacement of the vibrating particles is called as antinode. That position is called as antinode position. If in case of the displacement is minimum, that position is called as a nodes, means node position. The minimum displacement means here is the zero displacement or zero amplitude, also we can say it as zero amplitude or zero position. Here is the maximum amplitude or maximum position. Okay. So next. Here is how do we find out the values for nodes or antinode. The determination of node and antinode for the equations are. So the equation for the standing or stationary waves are, we can consider two progressive waves are traveling in a string along a straight line. If in case of the positive x direction, when the wave is traveling along the positive x direction, that is y of with respect to its time and position is k sine of kx minus omega t with when the wave is traveling along the positive x direction, and when the wave is traveling along the negative x direction is y2 of x comma t with respect to displacement of second wave, reflected wave, y2 of x comma t is equal to a sine of kx plus omega t. Kx plus omega t means that is moving in opposite direction. So that's why we are taking the two equations. Already earlier we have discussed about that. How do we take the waves? Whenever the wave is traveling along the positive x direction, we will take it as y is equal to a sine of kx minus omega t. And if in case of negative x direction, the equation will be y is equal to a sine of kx plus omega t. Earlier we have discussed about the equations, whereas displacement equations earlier. So from that, according to the principle of superposition of waves, according to the principle of superposition of waves, y is equal to y1 plus y2 be the equation for principle of superposition of wave. So in that case, if we substitute these two equations in this y is equal to y1 plus y2 equation, then we can get y is equal to a sine of kx plus kx minus omega t, and the y2 is equal to a sine of kx plus omega t. Two equations are substituted. Then from the mathematical formula, sine of a plus b plus sine of a minus b. From the mathematical formula, sine of a plus b plus sine of a minus b is equal to 2 sine a cos b. From the equation, the amplitude taken as common. So because of 2a sine a means kx and cos b means omega t. So that's why y is equal to 2a sine kx omega t. This is the equation for standing or stationary waves to formation, to take how much the distance for the nodes and antinodes, where the nodes and antinodes are formed. It depends on its length. and also its amplitude also is depends on its displacement also depends on amplitude also. Then when the normal nodes, condition for the nodes and antinodes, and how do we find out the nodes and antinodes, and how much the distance, what is the distance per nodes and antinodes in the given string. Then the condition for the nodes is the position of zero amplitudes. Zero amplitude means when the wave is traveling in this direction, then this will be the zero amplitude. Means when the wave is traveling in positive x direction or the negative x direction, doesn't mean that the maximum displacement is called as amplitude. It is the maximum displacement of vibrating particles. It's called as antinode. But in case of the amplitude is zero, means the minimum displacement of vibrating particles, there is no any amplitude. Amplitude is equal to zero. This is called as a node. The displacement, where the displacement of vibrating particles is zero, means zero amplitude. Zero amplitude is is known as a node position. Is called a node position. So that's why here it is a dash is equal to 0, means amplitude is equal to 0. From that equation then we can get sin kx is also 0. Sin kx is also 0. Then generally sin theta is equal to 0, then we can get theta is equal to n pi, because of where n is equal to 0, 1, 2, 3 up to so on. If we substitute the 0, then we can get theta is equal to 0, sin theta is equal to 0, 0, theta is equal to 0. Then we can get 1 pi, sin 180 is equal to 0. Like that, n is equal to 0, 1, 2, 3 up to so on. We can get how much the distance, the first loop, second loop, third loop, whatever it is. Then kx is equal to n pi. Kx is equal to n pi, because sin kx is equal to 0, then kx is theta is equal to n pi. Theta here it is the kx and 0 means by the n pi, so kx is equal to n pi. But we know the angular wave number. From angular wave number, that k is equal to 2 pi by lambda from the formula. K is equal to 2 pi by lambda. If we substitute this k is equal to 2 pi by lambda in the equation, then we can get 2 pi by lambda into x is equal to n pi. 2 pi by lambda into x is equal to n pi. If we cancel both sides, then we can get only whenever x is equal to lambda take it to this side, it will become the numerator, and lambda, the 2 is it in the numerator, whenever take it to this side, then it will become the denominator. So x is equal to n lambda by 2. Here is the n is equal to 0, 1, 2, 3 is the positions of nodes. Positions of nodes, the number of nodes. The 0 position means here the position is 0, number of 0. So that's why if you substitute this 0, x is equal to 0. Then x is equal to n is equal to 0 means x is equal to 0. Then here is the another node is there. Here it is n is equal to first node. Then first n is equal to 1. Then the distance will be the lambda by 2. Lambda by 2. Then if in case of the third node, here is the second node. 0 node, first node, second node. Second node means here is also one of the lambda by 2. Means lambda by 2 plus lambda by 2. 2 lambda by 2. This is the nodes are formed. In this position, the nodes are formed. This is the value we will find out that x is equal to n lambda by 2. This is the x is the position of nodes. X means by the position of nodes. So we will find out n is equal to x is equal to n is the 0 up to so n is equal to 0, 1, 2, 3 up to so on is the positions. X is the position, then the number of nodes are formed. N means by the number of nodes formed. From this equation we can get the what is the length? What is the length of the total nodes or antinodes are formed? Then this is about the condition for the nodes. Next we are going to discuss about the condition for antinodes. So the condition for the antinodes are the points of 0 amplitude is called as nodes, and now the points of maximum amplitude means where the amplitude is maximum, means when the wave is traveling in this direction, then the vibrating particles are at a high. It means maximum displacement. It's called as amplitude. The maximum amplitude of the points is called as antinodes. To know the condition for the antinode is amplitude is maximum. So that's why A bar is equal to 2A. From the 2A sin kx cos omega t formula, we can get amplitude is 2A. So that's why sin kx is equal to, we can get plus or minus 1. Meaning means where the maximum means it is at 90 degrees. So that's why we can set as that 90 degrees means the plus or minus 1. Either positive x direction will get the plus 1. If in case of negative x direction is we can get the minus 1. From the antinode condition, further when the vibrating particles are maximum, then according to the general solution, the sin theta is equal to plus or minus 1. So that's why we are writing that 2n plus 1 into pi by 2. Pi by 2 means 90 degrees. 90 degrees means here the theta is equal to 2n plus 1 into pi by 2. We can get that the maximum displacement value. So that's why we are taking that the k is equal to kx. If we know that from the angular wave number, k is equal to 2 pi by lambda. K is equal to 2 pi by lambda from the angular wave number. If we substitute this, k is equal to 2 pi by lambda in the above equation, then we can get by cancelling the pi of both sides, then 2 pi lambda into x is equal to 2n plus 1. Then according to the position of vibrating particles along the string in a straight line, then we can get x is equal to 2n plus 1 into lambda by 4. That means here if we where n is equal to 0, 1, 2, 3 up to so on, the positions of antinodes is the value number of antinodes. Here the n is called as the number of antinodes formed of the string, and x is the position of that antinode. So that's why we are taking that 2 of 0 means we can get that lambda by 4. If the first harmonic means first antinode, then n is equal to 1, we can get 3 lambda by 4. And the second antinode means here the distance is lambda by 4. First antinode. If in case of second antinode, the distance and position in second antinode is 3 lambda by 4. Means the distance from the initial position to the second antinode distance is 3 lambda by 4. At a distance from the origin to the 3 lambda by 4 wavelength, the length, then we can get the second antinode. And the third antinode, here is the third antinode, then we can get the third antinode is at the pi by 4, 5 lambda by 4, because of if in case of n is equal to 2 to the 4 plus 1, 5 lambda by 4 be the third antinode position. This is the third antinode position. The distance from the origin to the third antinode position is 5 lambda by 4. This is the about the antinode condition. But in these distances, in these positions, at the lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, in that position, the antinodes are formed in a vibrating string. Thank you. Hello everyone. Now the continuation for the part 8 is already we have discussed about that what is the position of nodes and antinodes. Means x is equal to 0 or wherever the positions of minimum amplitude is called as nodes, and where the maximum amplitude is called as nodes, already we have discussed. According to that, when the modes are formed, means whenever the vibrating string or vibrated between the two rigid supports, then it will form some of the loops are formed. Means whenever the modes are formed, in that case the types of modes of what is the determination, what is the values of modes of vibration, then the lowest possible natural frequency that can be a string or that can be a wave can be possible is called as a fundamental frequency. Means the minimum frequency which can the string can vibrate is called as it's a natural frequency, that is called as fundamental frequency. In case of the fundamental mode of vibration, first of all, when this is the one loop has formed, this is called as fundamental frequency, then what is the value? Means we know that the nodes 0, 1, the one node has formed, so that's why n is equal to 1, then length l is equal to lambda by 2. Already we know that position we have taken that x is equal to l, so that's why l is equal to lambda by 2. Then the wavelength is lambda is equal to 2l, wherever the cross multiplied, then lambda is equal to 2l we can get. From the equation for the speed of a wave, here we are going to tell them what is the modes of vibration means. So the speed of a wave, what is the fundamental frequency, what is the frequency to find out. Here is the v is equal to nu lambda is the formula for speed of a wave, speed of a traveling wave. From that, nu is equal to the fundamental frequency nu1, that nu1 is equal to v by lambda. From the formula, nu1 is equal to v by lambda, then we know that already value lambda is equal to 2l from the fundamental mode. From the fundamental code, lambda is equal to 2L, so that's why we are substituting in that one. V by 2L is the equation, the fundamental frequency when the wave are formed in an air. When the wave is formed in air. If in case of a string, we have to know that whenever the velocity or speed of a wave in a string is the v is equal to root t by mu is the equation for the speed of a wave. From that equation for string v is equal to root t by mu, if we substitute that by v value in the equation, then we can get mu1 is equal to 1 by 2L into root t by mu. This is the fundamental frequency or first harmonic. First harmonic or a fundamental frequency, we can say it is a fundamental frequency from the equation. Then the second mode of vibration means whenever the two loops are formed in a vibrating string, then 3 nodes and 2 antinodes are formed. 3 nodes and antinodes, 2 antinodes means 0, 1, 2. 2 nodes, n is equal to 2. From that, n is equal to the length of the loop is lambda by 2. Already from the first harmonic we have derived that. Then L is equal to lambda by 2. Same as n total length n is equal to 2. If we substitute this n is equal to 2, then we can get n lambda by 2, 2 lambda by 2. From this equation, lambda is equal to, we know that whenever cross multiplied, then lambda is equal to 2L by 2 value. From this equation, we have the equation for nu is equal to v by lambda. From the equation fundamental frequency, so nu2 is equal to v by lambda. From that equation 2v by 2L, this is the value, the frequency, second fundamental frequency means second harmonic or first overtone, which is called as the second harmonic or first overtone. So in the second harmonic or first overtone, if in case of a vibrating string, if the modes are happened in the vibrating string, if the vibrating string v is equal to root t by mu is the formula for velocity. If we substitute that velocity is equal to root t by mu formula in the equation, then we can get nu2 is equal to 2 by 2L root t by mu, because of v is equal to root t by mu. This is the formula for second harmonic or first overtone in a when the modes are happened, modes are made in the vibrating string. Then mu2 is equal to 2 by 2L root t by mu. But we know that from the fundamental frequency mu is equal to 1 by 2L root t by mu. 1 by 2L root t by mu. So we can write 2 into 1 by 2L root t by mu. From that equation we can write mu2 is equal to 2 into mu1. mu2 is equal to 2 into mu1. That is the second harmonic or first overtone. And the third harmonic mode is we can write that whenever the 3 loops are formed, then 1, 2, 3, 4 means 0, 1, 2, 3. And n is equal means n is equal to 3. N is equal to 3. And antinodes are 3 formed. So that's why n is equal to 3. The number of nodes are 3. So that's why from n is equal to 3, then L is equal to, we know that 3 lambda by 2 we can get. By the calculation, the nu3 means the third harmonic or second overtone. Nu3 is equal to v by lambda. But we know that lambda is equal to 2L by 3. If we substitute that value of 3v by 2L with the equation we can get. For a string, v is equal to root t by mu, nu3 is equal to 3 by 2L root t by mu. Or we know that 1 by 2L is equal to 1 by 2L root t by mu is the fundamental frequency, that is mu1. If we substitute this one, nu3 is equal to 3 nu1 is the third harmonic and second overtone. Third harmonic and second overtone. If the continuous the modes, how many modes are happened in the vibrating string, then we can calculate the total means if the number of modes are vibrated in a string means number of modes means here in general the frequency of nth mode. Frequency of nth mode of vibration in a string, then we can get for a nu n is equal to nv by 2l, nv by 2l. Then here the total we can get that v by 2l means there is the nu1 means v by 2l is the nu1 means fundamental frequency. So that's why we can write that nu n is equal to number of loops happened, number of modes happened, number of modes into nu1. Number of modes into nu1, so that's why nu n is equal to n into nu1. So the nodes so produced is called nth harmonic. The nodes so produced with the nth harmonic. Then n minus 1th overtone It's less than 1, minus 1. The number of harmonics, how many number of harmonics formed in a loop? Then that is minus 1, n minus 1 tapo over 2. Means this is the modes of vibration. Whenever there is string or in air, we use the fundamental frequency is V is equal to V by L. Nu is equal to V by L, and nu is equal to a string 1 by 2 L to T by nu. Because of string is having that, whenever we vibrate that string, it contains some tension developed in the string, and at the same time depends on its linear density also. So that's why we are containing that. Here L is also length. It depends on the vibration is depends on the length also. Because of if the length is more, the number of modes are formed. Then obviously the tension will be developed less, and at the same time here the linear density also depends on the frequency. So that's why here the modes are happened when the fundamental frequency is depends on that length, tension, and its linear density also. From that, if there are three laws are there in the whenever the modes of vibrating a stretched string, then the three laws are. So the laws of vibrating strings are three times. The three laws of vibrating strings are: when the string is vibrates n loops, then the frequency of the vibrating string is mu n is equal to n by 2L root T by nu. When the string vibrates in n number of loops are formed, it depends on its loop. So that's why here the fundamental frequency depends on its length, means and at the same time tension, and its linear density. Means if the density is more, the frequency will be less. The density is more, frequency will be the less. If the more tension is developed in the string, then its frequency will also increase. For example, guitar, sitar, the musical instruments, whenever we played, then if the string's density is more, then the sound and the vibrations, the frequency will be less. We can't hear the more voice or more sound and more frequency, more oscillations from that string. So the less density strings are used. Whenever you use the more tension of the string can be break. So here the frequency also depends on the tension, linear density, and at the same time its length also. If the length is more, then frequency will be less. So that's why here the three laws of vibrating string is there. The first one is law of length. The law of length. The fundamental frequency of a vibrating string. The fundamental frequency of a vibrating string is inversely proportional to its length of the string. It's a length of the string. Earlier we already discussed about that. When the length of the string is more, and its frequency will be less. For example, if we take the long length of the string and we vibrate, then the frequencies will be less. Like that. If the length of the string is more, then we can hear that in the guitar. If we vibrate the string for long length, then we can't hear that much of frequency, that much of sound. Whenever the length is decreases, the frequency will be more. So that's why we can say that the fundamental frequency of a vibrating string is inversely proportional to its. If the length is decreases, then its frequency will be increases. Then so that mu1 by mu2, from that mu L is equal to constant. From that formula we can write that mu1 by mu2 is equal to L2 by L1. Then next, second equation. The second equation is the fundamental frequency mu is directly proportional to the square root of its tension developed in the string. Means the fundamental frequency is directly proportional to the square root of the tension in the string. Because of whenever we vibrate the string, then the string, if more tension developed in the string, then we can hear the more frequencies, more sound. If the string is normally get tensed, then we can hear the less frequency. So here the fundamental frequency nu is proportional to directly proportional to square root of its tension. If the string get more tension, then the frequency will be more. If the tension is get less tension, then frequency will be also less. But so that nu is proportional to root t, that is equal to nu by root t is equal to constant from the nu1 by nu2 is equal to root t1 by t2 is the equation we can write. Next the law of linear density. Law of linear density. Law of linear density means if the thickness is nothing, density is nothing but if the string is more density, having the more density, like normal strings are used to the for the musical instruments and whatever. If we replace that one with more density strings, then that can't vibrate like normal strings which is used to for the musical instruments, because of it is having density more, the density more or less, but that string can't vibrate the normal strings are used to the musical instrument. So that's why it depends on the density also. So that's why we are saying that the fundamental frequency of vibrating string is inversely proportional to the linear density of the string. Linear density of the string. If the string is more dense, then we can get the less frequency. So that's why nu is proportional to 1 by root mu, that is equal to nu root mu is equal to constant, and that nu1 by nu2 is equal to root mu2 by mu1. This is the laws of a vibrating string. Once again, we have the three laws of vibrating string. The first one is a law of length, and second one is law of tension, and third one is a law of linear density. Law of length means the fundamental frequency of a vibrating string is inversely proportional to the length of the vibrating string. That is, mu is proportional to 1 by L. And the second one is law of tension, means the fundamental frequency is directly proportional to the square root of its tension. If the tension is more, the frequency is also more. Then mu is proportional to root to t, that is mu by root t is equal to constant. From that, mu1 by mu2 is equal to root to t1 by t2. Next one, law of linear density. The fundamental frequency of a vibrating string is inversely proportional to the square root of its linear density. Mu is denoted with the linear density, and root mu is equal to constant. Mu by mu is equal to root mu2 by mu1 is the formula of the law of linear density. By using this law of vibrating string, we can find out that from the three formulas, we can get the equation. We can get the equation for the vibrating string. Hello everyone. Today we are going to discuss about the standing waves in a air column. Means before video we have discussed that what is standing waves and what are the equations and what are the laws of vibrating string. When the standing waves are formed, means when the string is vibrated, then what is the standing waves are formed in a string. Then laws of string also we have discussed in previous video. Now we are going to discuss about stationary waves in air column. Means here the air enclosed in a pipe is called air column. That means whenever if we take some of the test tube, by blowing the air in the test tube, we can hear the note. We can hear some of the note. Or for example, in our childhood also we did that when we take the pen cap. If we take the pen cap, if we blow the air in the pen cap, then we can hear the sound note pitch, some of frequency. So those are called air columns. The standing waves formed in air columns. Here, when air column is formed in a closed end, means closed pipe. What is meant by the closed pipe? The one side of the pipe is open, and another side of the other side of pipe is closed, is called a closed pipe. In other hand, the pipe is open at both ends is called open pipe. The air columns can be formed in open pipe and closed pipe also in many ways, in many different type of frequencies. If the notes are formed in a air columns are formed in a pipe in many ways with making notes of which is a complex note. Is a complex note. If we take the closed pipe, then here whenever the air enters, then at the closed side only the air particles does not move freely. They don't move freely. So that's why here note will be formed. And on the other hand, if we take the open end, means at the open end, if the open end, the antinote will be formed because of air particles can move, maximum freedom is there. They can move in any part. So that's why here antinote will be formed. Here that when the air columns are formed in a, the standing waves are formed in a tube or air columns, then the mode of vibration with the lowest frequency. When the air columns formed in a tube, the mode of vibration with the lowest frequency. The mode of vibration with the lowest frequency is called as the fundamental mode. It's called a fundamental mode. And the lowest frequency which can be formed in a column is the fundamental frequency. The mode of vibration with the lowest frequency is called a fundamental mode. And the frequency is called a fundamental frequency. The next one, when the frequency, the mode of vibration produces notes more than the other than the fundamental modes. More than the fundamental modes, if the modes of vibration produces notes of higher frequency, then that note is called overtones. The modes of vibration produces a note with high frequency. Notes of higher frequency are called overtones. Means wherever blow the air, then air column will be more. If the air column will be more, then the frequency of sound will be different. Means not the fundamental frequency. The frequency doesn't mean that whenever the air column forms, that only the sound we can hear, the pitch we can hear. Now otherwise we can't hear the sound. So here whenever the mode of vibration produces notes of higher frequency, then that is called as overtones. If the frequency of overtones are the integral multiple of fundamental frequency, means if the sound fundamental more than the fundamental frequency, the overtones are going increasing. The integral multiple of fundamental frequency are called harmonics. So that's why we are saying that here the fundamental frequency are first harmonic. If in case of second mode of vibration, earlier we have discussed in previous video in modes of vibration. The second one is the second harmonic or first overtone. Whenever the air columns are formed, standing waves are formed in a air column, in some string or in whatever the medium is there, then when nth harmonics and n-1 overtones will be formed. Already we have in previous video discussed about it. So here the mode of vibration with lowest frequency are called the fundamental mode. The frequency is called as fundamental frequency. When the mode of vibration produces notes with higher frequency are called overtones. For the frequency of overtones or integral multiple of fundamental frequency is called harmonics. So in the harmonics, now we have already discussed about that the air columns formed in pipe, means then closed pipe and open pipe also. Now the modes of vibration of air columns in an open pipe. What is meant by the open? Means pipe opens. Pipe is open at both ends. Open at both ends is called a open pipe. In that open pipe, when the fundamental frequency means the fundamental mode of vibration will be happened, then the two antinodes, between the two antinodes, one node will be formed. When in the fundamental mode of vibration in an open pipe, fundamental mode of vibration in an open pipe, then already we have earlier discussed whenever the open side antinodes are formed, so that's why both ends are open. So that's why two antinodes and one node are formed. And as well as when the length of the A column will be, denoted as with L, then lambda 1 be it's a wavelength, fundamental wavelength. Then the wavelength of this A column is, we have that this one is the distance between the two consecutive or two adjoining node to the distance between the node to adjoining antinode, or the distance between the antinode to adjoining node, means this is the adjoining node to the antinode, is called a lambda 4. The length will be the lambda by 4. And also here the distance between the node to the adjoining antinode is also lambda by 4. So here it is that lambda by 4 plus lambda by 4. Lambda by 4 plus lambda by 4 is a 2 lambda by 4. That means L is equal to lambda by 2. That means here we can write that lambda by 4, lambda by 4. So from that L is equal to lambda by 4 plus lambda by 4. That is 2 lambda by 4. 2 1s are, 2 2s are, total we can get L is equal to lambda by 2. From that, if lambda 1 is the wavelength, then whenever the A column happened in this fundamental mode of vibration, the fundamental mode of vibration is called lambda 1 is the wavelength, the fundamental wavelength for this A column. The wavelength is the lambda 1. So wherever L is the length of A column, then L is equal to lambda 1 by 2. Lambda is the wavelength, lambda by 2 is the length of each column. So lambda 1 is equal to 2L. Lambda 1 is equal to 2L. Then if nu1 be the fundamental frequency, if nu1 be the fundamental frequency, we know that nu is denoted as frequency is denoted with the nu, like that. Here when the fundamental frequency nu1 be the fundamental frequency, then V is equal to, we know the formula, when the speed of a wave in air is V is equal to nu lambda. There is no another medium, means like string. Only the A columns are formed in a tube, so that's it. So the frequency will be, we are measuring. So V is equal to nu1 lambda 1. Nu1 be the fundamental frequency, lambda 1 be the wavelength. Then nu1 is equal to V by lambda 1. The lambda 1 will be the, if we take this outside, it will become denominator. Then nu1 is equal to, lambda 1 is equal to, from the equation 1, lambda 1 is equal to 6, lambda 1 is equal to 2L. We are substituting that one V by 2L. Here nu1 is the fundamental frequency. In an open pipe, this is a V by 2L is the equation for the fundamental frequency. We should remember that one. Then nu1 is called as fundamental frequency, or a first harmonic, fundamental frequency, or a first harmonic. This is the fundamental mode of vibration in an open pipe. The next, the second mode of vibration. In the second mode of vibration, always we know that at open end antinode is formed. At open end antinode is formed. At closed end node is formed. Just don't be confused. At open end antinode is formed. At closed end node is formed. So here at both ends the antinodes are formed. Between the antinodes, two nodes are formed. Total 3 antinodes and 2 nodes. 3 antinodes and 2 nodes. So here three antinodes and two nodes are formed, the length of the air column will be in an open pipe. L is equal to lambda by 4 because of the adjoining lines. Here the antinode to the adjoining node is lambda by 4 and the distance between the two consecutive nodes or antinodes are called distance is lambda by 2. So lambda by 2 means the node to the node distance will be lambda by 2 plus lambda by 4. So here lambda by 4 plus lambda by 2 plus lambda by 4 is the 4 lambda 2 by 4. Then 2 lambda by 2 is equal lambda 2 is equal to 2L by 2 we can get. So here is that nu 2 is the second mode of frequency, means frequency of vibration nu 2. That is called as the second harmonic or first overtone also we can say that. So nu 2 is the frequency of air column in an open pipe, thus in the second mode of vibration. In the second mode of vibration. So nu 2 is equal to V by lambda 2 is the formula, as we know that for the speed of a wave in A. Then nu 2 is equal to lambda 2 is equal to, already we know that 2 lambda 2L by 2 is the length of air column, means wavelength of air column. Then u2 is equal to b by 2L by 2. From this 2v by 2L. Because of denominator, the 2 is the denominator for denominator, so that's why it becomes numerator. Then 2v by 2L. Here 2v by, we know that v by 2L is the fundamental frequency nu1. v by 2L is the fundamental frequency nu1. So that's why we are writing that mu2 is equal to 2 nu1, since nu1 is equal to v by 2L from the fundamental frequency. As that we can say that nu2 is the first overtone. Nu2 is the first overtone and or second harmonic. Second harmonic. Further, in the next mode of vibration, the air columns formed in an open pipe. When this one is the first fundamental frequency, as we know that, and this one is the second harmonic or first overtone was in before earlier we have seen, and when in the next mode of vibration will be another harmonic or fundamental frequency also formed, and this will be the next mode of vibration. The next mode of vibration, the antinodes are 1, 2, 3, 4. Means 4 antinodes and 1, 2, 3 node. Means 3 nodes are formed. In that 3 nodes are formed whenever the next mode of vibration is called as, this is called as the third harmonic or second overtone. Third harmonic or second overtone. So here the wavelength will be, the length of air column L is equal to, here the adjoining node to the antinode is lambda by 4, lambda by 2, lambda by 2 plus lambda by 4. Totally we can get when 6 lambda by 4. 6 lambda by 4, by doing LCM we can get 6 lambda by 4. 1, 2, 2 lambda, 4 lambda, 5, 6 lambda by 4 we can get. So L is equal to 6 lambda by 4. From that L is the length of air column. Then L is equal to 6 lambda by 4. That is equal to lambda with the lambda 3, because of lambda 3 is the wavelength of third harmonic. So that's why we are writing that lambda 3. So lambda 3 is equal to 4L by 6. That is 2L by 3. 2 to the 2 3 the. From that 2L by 3. Here lambda 3 is the wavelength. and nu3 with the frequency of vibration, frequency of vibration, frequency of vibration. Then from the frequency of vibration we can write that V is equal to nu3 lambda 3, that is equal to nu3 is equal to V by lambda 3, V by lambda 3, that is equal to nu3 is equal to V by lambda 3 means 2L by 3, that is equal to 3V by 2L, means nu3 is equal to 3 nu1 from the fundamental frequency. From the fundamental frequency we can write that nu3 is equal to 3 nu. For n number of modes will be formed in a open pipe. If n number of modes are formed in a open pipe, then we can get in general equation for the air columns the frequency in an open pipe. General formula for frequency in an open pipe is mu n is equal to nv by 2l. Mu n is equal to nv by 2l. We can write that mu n is equal to nv by 2l, or mu n is equal to n mu1. These two are the general fundamental equations for n number of modes. Means first number of mode, fundamental mode happened when n is equal to 1, 2, 3 up to so on. So we can write that where n is equal to 1, 2, 3 up to so on. We can write it. This is about when the air columns formed in an open pipe. For Telangana and Andhra Intermediate Board of Education, the open pipe question, and at the same time in previous class we have discussed about the standing waves, means in previous videos part 8 and 9, the standing waves, that is the first long answer question, and this will be the open pipe. He asked for the long answer question for 8 marks in Telangana and Andhra Board of Intermediate Education. According to the Board of Intermediate Education, this is the 8 marks long answer question. Okay, the most important question in 8-9 videos, and this one also. Thank you. So, modes of vibration of air columns in an open pipe. The frequencies are found fundamental frequency and first harmonic, or second harmonic, first overtone, or third harmonic, the first overtone. The modes of vibration will happen. Then the ratios of frequencies of normal modes of vibrations are u1 is to u2 is to u3 is equal to 1 is to 2 is to 3. We can get in the open pipe. So in general, the equations of frequency for nth mode of vibration is mu n is equal to nv by 2l. Here nv by 2l means where n is equal to 1, 2, 3, 4 up to so on. We can write that. So from that equation, mu n is equal to nv by 2l and nv1. If in case of first mode of vibration, if n is equal to 1, then v1 is equal to v by 2l, the fundamental frequency. In that second mode of vibration, then say 2n is equal to 2, then if we substitute 2v by 2l with the second mode of vibration, that is the second harmonic or first overtone. Like that, we can get the n is equal to 1 to n number of harmonics will be possible. That is the nth harmonic. The notes are formed, and the next one is the overtones are formed in that n minus 1 of harmonic. Here is this is the modes of vibration of air columns in an open pipe. Thank you. Hello everyone. Yesterday in before video we have discussed about standing waves of air columns or modes of vibration of air columns in an open pipe. So in that video we have discussed the fundamental frequency and first harmonic, as well as second harmonic, whenever second mode of vibration, the first two overtones, second harmonic, and in a third sound of modes of vibration, then second overtone, third harmonic happened, and the ratios of frequencies are mu1 is to mu2 is to mu3 is equal to 1 is to 2 is to 3. and the equation will be nu n is equal to nb by 2l when the modes are happened. Now we are going to discuss about the mode of vibration of air columns in a closed pipe. What is closed pipe? Closed pipe means a pipe which is open a side and closed another side is known as closed pipe. In the closed pipe, the closed end always node is found because there is air particles are not free to move at the end of the closed pipe. So always at end side of closed pipe is node is found. In that case, first the mode of vibration. And the first mode of vibration is called fundamental frequency or first harmonic. In that case, in the first mode of vibration, this is the closed pipe. Or we know that at the ending open state, the antinode is formed, and as well as at the end side, the node is formed. And the length of the air column will be the adjoining node to antinode distance is the lambda by 4. Lambda by 4 is the length of the air column in the closed pipe. So, in fundamental mode of vibration, length of air column L is equal to lambda by 4. So from that, then the wavelength will be lambda is equal to 4L. Lambda is equal to 4L. Then we know that the length of the air column is lambda by 4 and the wavelength is 4L. Then the frequency nu1 with the frequency means fundamental frequency. Nu1 with the fundamental frequency, that V is equal to nu1 into lambda. From the case we can write that nu1 is equal to V by lambda. Nu1 is equal to V by lambda. From that nu1 is equal to V by 4L. This is the fundamental frequency or first harmonic. Fundamental frequency or first harmonic. This is called a fundamental frequency or first harmonic. Fundamental frequency. Here known is the fundamental frequency or first harmonic. Then next when the second mode of vibration is happened, that is called as the third harmonic. Third harmonic or second to first over 2. So here is the third harmonic or first overtone. In the first overtone, then the air column in a closed pipe will be formed like this, and this is the fundamental frequency already happened. Then this will be the always at the end of the node will be formed, and here also node will be formed. Here two antinodes and two nodes are formed. Two antinodes and two nodes are formed. Two antinodes and two nodes formed. Two antinodes and two nodes are formed. Then the length of the air column in an open pipe is closed pipe is open side. This is the lambda by 4 to up to adjoining side of node. Then the distance from the node to the node is lambda by 4. Lambda by 4 plus lambda by 2. This is the distance lambda by 2 and lambda by 4. Then totally we can get that 3 lambda by 4. So here is the length of air column. Length L is equal to 3 lambda by 4, and as well as here wavelength will be lambda is equal to 4L by 3. Here is that lambda is equal to 4L by 3. When the 4 taken to this side, then 4L and 3 will be denominator whenever taken to this side. So lambda is equal to 4L by 3. Then frequency nu3. Frequency nu 3. Then the frequency nu 3 is equal to, V by lambda. V by lambda. So from the nu 3 is equal to V by lambda is equal to, we know that 4L by 3. So 4L by 3. From that nu 3 is equal to 3V by 4L. 3V by 4L. From that 3V by 4L, we can write that nu 3 is equal to 3 into nu 1. Because we know that from the fundamental frequency of a column in a closed pipe, nu 1 is equal to V by 4L. So that's why we are writing this. Nu 3 is equal to 3V by 4L. And here the next harmonic will be fifth harmonic or a second overtone. Here in the third harmonic, the length will be the L is equal to 3 lambda by 4, and as well as wavelength is equal to lambda is equal to 4L by 3. From that, frequency in third harmonic or first overtone will be frequency nu 3 is equal to V by lambda, as we know that from the speed of a transverse wave. From that, nu 3 is equal to V by 4L by 3. That is the equation. Then lambda value will be substituted in this equation. Then nu 3 is equal to V by 4L by 3. Next nu 3 is equal to 3V by 4L. Whenever the denominator take into the numerator, then 3V by 2L. But we know that from the fundamental frequency in of air column in a closed pipe, then nu 1 is equal to V by 4L. So that's why we are substituting that one fundamental frequency. Then nu 3 is equal to 3 nu 1. This is the third harmonic or first overtone. The fifth harmonic and or second overtone, the air column is formed in a closed pipe case. This is the equation. This is the air column is formed. The antinode at open side, and here is another one antinode, and here is another antinode, and this will be the node. In this fifth harmonic or second overtone, the total 3 antinodes and 3 nodes are formed. 3 antinodes and 3 nodes are formed. Then here is the length of a column. Length of a column will be, here L is equal to lambda by 4 plus lambda by 2 plus lambda by 2. Lambda by 4 plus lambda by 2 plus lambda by 2. Totally we can get that 5 lambda by 4. That L is equal to 5 lambda by 4. So L is equal to 5 lambda by 4. From that wavelength, lambda is equal to 4L by 5. Lambda is equal to 4L by 5. When you want to 4 take into this side 4L, 5 lambda is equal to 4L. Then lambda is equal to 4L by 5. It is the wavelength. Then frequency in fifth harmonic, frequency nu 5 is equal to V by lambda is the formula of we can get the formula of frequency from the speed of a transverse wave. So nu 5 is equal to V by lambda. From that V by lambda is equal to 4L by 5. 4L by 5. Here the 5 is the denominator for the denominator, so that's why it will become numerator. Then nu 5 is equal to 5V by 4L. That is equal to nu 5 is equal to 5 nu 1, because of from the fundamental frequency, as we know that nu 1 is equal to V by 4L. This is also equation for the fifth harmonic or second overtone. Fifth harmonic or second overtone. For the ratio of frequencies, the ratio of frequencies, that is nu 1 is to nu 3 is to nu 5 is equal to up to so on is equal to 1 is to 3 is to 5 is to up to so on. We can get the odd numbers of when the general expression for the the general expression or general equation for nth mode of normal, nth normal mode, nth normal mode, nth normal mode. Brother, general expression for the nth normal mode will be already as we know that nu n is equal to 2n minus 1 into lambda by 4. Sorry, v by 4l. V by 4l. 2n minus 1 into v by 4l. So nu n is equal to, we can write that 2n minus 1 into nu 1, because from the fundamental frequency we know that nu 1 is equal to v by 4l. So nu n is equal to 2n minus 1 into nu 1. This is the equation for general expression for the air column, mode of vibration of air columns in a closed pipe. This is the equation. Then here is the node is produced. The node is produced. The node is produced for that 2n minus 1 the harmonic. Harmonics will be 2n minus 1 the harmonic. And as well as the overtones are 2n minus 3, 2n minus 3 overtones. Overtones for the nodes are produced. This is about the modes of vibration of air columns in a closed pipe. Thank you. Hello everyone. Today we are going to discuss about end correction for reflection at open end. End correction for reflection at open end. That means when the air columns are formed, when the air columns are formed in a open pipe or closed pipe, at the open end side the antinodes are formed because of the air particles are free to move in maximum, so that's why antinodes are formed at the open end already we know. At closed end, due to the air particles does not move freely, so that's why their node will be formed at the closed end. Due to the reflection of air particles, means air column, in air columns the reflection of air, at the open end antinode form we will know that. But according to this, exactly the antinode will not form at the open end. Exactly the antinode will not form at the open end. Means whenever due to the reflection, the antinode will not form at the open end exactly, but the farther away from some of the distance. That error occurred. So to correct that error, the end correction is called. The correction of that error is called a end correction. According to the Lord Rayleigh has given the theoretical value for the end correction, that is a 0.62 Rayleigh. That is the theoretical value. 0.62 Rayleigh. That is the theoretical value. According to that value, whenever the R means the internal radius of the tube, whatever the tube we are taking that, this is the tube. The internal radius of the tube. The internal radius of the tube will be the R capital. If we wherever we multiply 0.62 into internal radius of the tube, then we can get the value exactly point of antinode. First of all, the antinode according to the Rayleigh does not form at the end of the operand, but the farther away from the operand. So the distance error is occurred. The length of air column will be some of the error is there. So to correct that error, Rayleigh has given the theoretical value, that is 0.62 Rayleigh. That 0.62 Rayleigh means R means here the radius means internal radius of the pipe. So according to this is the end correction. Next we are going to discuss about resonance. What is meant by the resonance? First of all, what is meant by the resonance? The resonance means here when the frequency of external applied periodic force, on your body is equal to its natural frequency, the body rapidly begins to vibrate. with an increasing amplitude is called resonance. That means whenever one body is vibrated by the external periodic force, due to the vibrations, if the opposite body having the same natural frequency, it is having the natural body, the other body's natural frequency, the frequency of externally applied periodic force, frequency which is equal to the another body's natural frequency, then that another body is also start vibrating. That is called as resonance. That phenomenon is called as resonance. Once again, when a frequency of external applied periodic force on your body which is equals to its natural frequency of the body with increasing amplitude, then the body rapidly begins with an increasing amplitude is called resonance. For example, if we take the four pendulums with a fixed support of x and y, fixed resistance support x and y, some of the four pendulums are taken, which is A is very small, short than the others, and B and D are having the same length, which is identical. Both are B and D are identical, and C is a log. Here, four pendulums are taken. The A is small in small in length, and B and D are same in length, greater than the A, and C is more greater than the all of the others. Then, if we set into oscillations, the B body set into vibrations, then all the pendulums will vibrate. But here is the pendulum D will start oscillating with the same frequency and they increase the amplitude with the equal to the B because the both are having the same length and same natural frequency. Whenever B vibrates, B set into oscillations, then with increasing amplitude, D also oscillates with increasing amplitude. So it is said to be that this is called as the resonance. So B and oscillate same frequency and amplitude than the A and C. At the starting, whenever B or D set into oscillations, all the pendulums will oscillate. But here the B and D will oscillate with the same frequency and amplitude. This is the one of the example for the resonance. Another one is there. Here the two equally same natural frequency, equal frequency of two tuning forks are fixed to the hollow wooden box. This is the hollow wooden box fixed into the tuning forks, so they having the same frequency, same natural frequency fit into the hollow wooden box. Then for A, tuning fork vibrated with some frequency. Then due to that, whenever the hollow, the vibrations will meet the B with same frequency. Also B started vibrations with the A same increasing with the body A. Means whenever we set into the vibrations A tuning fork, then automatically the vibrations are moved to the B through the tuning fork A, and that B tuning fork is also vibrates with the same frequency and amplitude due to the resonance. And one more thing is, whenever band of soldiers are doing march past, then when they step out from the march past at the bridge, why? Because if they do the march past in the bridge, if the natural frequency of the bridge which is equal to the marching, then that bridge will start oscillating. Finally, that may collapse. So that's why, due to the resonance, that's why soldiers step out from the marching during passing from the bridge. That is due to the resonance. And one more thing is, whenever if we take the strings of violin, sitar or guitar, then whenever we fix the two equally frequencies strings, then vibrate one string, then another string also reaches the same frequency due to the vibrations of the first string due to resonance. As well as like that, we can see more our livelihood examples due to the resonance we can feel. Thank you. Once again, The resonance means when the frequency of external applied periodic force on your body is equal to its natural frequency, the body readily begins to vibrate with an increased amplitude. This phenomenon is called resonance. Because of effect of one body, when the one body is vibrating, due to the effect of the vibrations, when the natural frequency of another body which is equal to the vibrations frequency, then this body and the second body also start vibrating. That phenomenon is called as a resonance. That phenomenon is called as a resonance. Due to that resonance, here is some examples which is how the pendulums we have taken. Whenever the B and B are having the same length, then when the B is set into oscillations, then the D also, the pendulum D also oscillates with the same frequency and amplitude. And another one is when we take the two tuning forks of same frequency fixed into the hollow wooden box, then whenever here the tuning fork A is vibrated, then due to the resonance, whenever the vibrations reach to the body B and set into vibrate, due to the effect of the A, second tuning fork also vibrates with the natural frequency of its how the frequency is having by the A. So both will be vibrates with the same frequency and amplitude due to the resonance. And one more thing is, whenever the band of soldiers marching on the bridge, they step out. Why? Because if they step on the bridge, the frequency of the marching if equals to the natural frequency of the bridge, then the bridge start oscillates and may collapse. So that's why when they are doing marching on the bridge, they will step out from the marching, they will walk normally. They don't do the marching on the bridge. This is, and in livelihood we can see the sitar, guitar, the musical instruments, the type of activities. When we set into vibrate with the equal frequency strings are fitted to the musical instruments, then whenever one string is vibrated, another string also will vibrate with the equal amplitude. Hello everyone. In previous video, we have discussed about that resonance. What is resonance and what are the examples we have discussed? Resonance means simply we can say that whenever one body vibrates because of another body vibrations. Whenever this body vibrations reach to the natural frequency of another body, then another body is also start vibrations to equally to this body. That is called as a resonance. Simply we can say that. In this resonance, by using the resonance tube, we can give the velocity of the speed of a sound in air. This resonance tube contains the reservoir, and what stand which is reservoir is has to move in vertical of movable reservoir, and a scale to measure the water levels. The pipe is fixed to see the water level, and the tube, brass or glass tube fixed to the another part. When the glass tube is filled with the water, then equal levels of water we can get in the brass or glass tube and also in the pipe also. By pouring the water in the reservoir, we can get the total water levels because of these two are connected. These two are connected and levels will be the equal. By moving this water reservoir, we can maintain the water levels in the tube and in this pipe. We can measure by using the scale. First, these are fixed to a stand. Then, now we are going to see what are the air columns formed in a closed type. This is like a closed type of pipe. Then, when the vibrated tuning fork taken to the open side of the tube, then by moving this reservoir, we can maintain the water levels by taking this reservoir downwards, then water level will also comes to downwards. When it comes to downwards at some level, we can hear the sound when the vibrated tuning fork taken to the open side of the tube, we can hear the sound. That level length by measured in the tube, in the pipe by using the scale, that length will be L1. This is the L1. Whenever the one column, air column, we can hear the vibrations, then that is the level a node is formed. So that's the level will be, that is a lambda by 4, that is first harmonic. That is first harmonic level. So L1 is equal to lambda by 4. Whenever the L1 is equal to lambda by 4, then what is the speed of a sound in air is L1 is equal to lambda by 4. In that, lambda is equal to 4L1. From that, V is equal to nu lambda formula from the velocity of a wave. Then nu is equal to V by lambda. If we substitute this value, nu is equal to V by 4L1. That is the closed type of fundamental frequency or first harmonic. Nu is equal to V by 4L formula. From that, velocity of a sound in air, by taking the speed of a sound in air, V is equal to root of gamma P by rho. Gamma P by rho. From that formula, the formula substituted in the equation, then nu is equal to 1 by 4L1 root gamma P by rho. Gamma P by rho. From that, here again, we taking this water reservoir downwards to maintain the another level, to form the another air column, another level of air column mode of vibration, another mode of vibration. Then we can get that another the tuning fork taken to the top of the pipe tube. When the vibrated tuning fork taken the top of the tube, then we can get another sound also. Then that will be the third harmonic or first overtone. The length as taken as L2. L2 is the 3 lambda by 4. From that, L2 is equal to 3 lambda by 4. Then the differences between the L12 minus L1 is equal to 3 lambda by 4 minus lambda by 4 equation. Then we can get lambda by 2. From that, lambda is equal to 2 of L2 minus L1 be the equation. From this, we can find out the speed of the sound in air is V is equal to nu lambda. V is equal to nu lambda. If we substitute this lambda is equal to 2 of L2 minus L1, then from that we can find the velocity of a sound in air in a tube by resonance tube. In resonance tube, V is equal to 2 nu into L2 minus L1. Already we know that at open side, due to the reflection of wave, the antinode will not exactly form at the open end. There is some farther away from the open end. Already we have discussed in previous video. But so that there is some end correction is there. So that here the end correction will be at the first column, whenever the first harmonic is happened, that is L1 plus E. E means end correction. E is equal to end correction. L1 plus E is equal to lambda by 4. And L2 plus E is equal to 3 lambda by 4. When the third harmonic and our first overtone is happened, then also some of the end correction is there. So that here is also end correction is there. So L2 plus E is equal to 3 lambda by 4. By taking, already we know that lambda by 4 is equal to L1 plus E. If we substitute in this lambda by 4 place, instead of lambda by 4, if we write that L1 plus E, then we can get L2 plus E is equal to 3 of L1 plus E. By the calculation, we can get L2 plus E is equal to, whenever we multiplied inside, then 3 into L1, 3L1 plus 3E. Then by calculating this, L2 minus 3L1, whenever 3L1 taken to this side, then L2 minus 3L1, when the E is taken to this side, 3E minus 2E, 2E, then E is equal to L2 minus 3L1 by 2. This will be the end correction formula in the resonance tube. Once again, when we used the resonance tube, first the reservoir is moved to maintain the water levels in the tube. So that's why at the sum of the level, if we vibrate the tuning fork, we can hear the sound. That is the first harmonic. In any point, at all the points, we can't hear the sound. at the sum of the point whenever that reach to the equal to the first harmonic or third harmonic or fifth harmonic, then only we can hear the sound. Otherwise we can't hear any sound whenever the vibrated tuning fork taken to the top of the open end. Only the water levels whenever we maintain by the harmonic, whenever the length of air column reach to the first harmonic, which is equal to lambda by 4 or 3 lambda by 4 or 5 lambda by 4, then only the sound we can hear. So L1 is equal to whenever the length of air column reaches to the lambda by 4, means and the distance of antinode and node, then only the L1 is equal to lambda by 4 will come. After that, by we changing the water levels, we use to do more times by vibrating the tuning fork and put the tuning fork at the top of the tube. By doing this again and again, at some of the level, some of the point, some of the distance, we can get another sound also. Whenever we hear that the maximum sound and minimum sound, we should hear that by moving that 1 or 1.5 centimeter upwards and downwards, or 0.5 centimeter upwards and downwards, the minimum sound and maximum sound. Is that sound is perfectly coming at the point or not, to verify that the minimum sound and maximum sound. So here is that by taking the L1, L2 values, we can get the equation that is V is equal to 2 nu of L2 minus L1. There is, whenever there is some of the end correction is there, then we should follow that. Already we know that from the Rayleigh, the end correction is equal to 0.61 R. R means radius of internal tube, means internal radius of the tube. Whatever the tube we are taking that, the internal radius, this is R. R means internal radius of the tube. This is the about a resonance tube. By using this one, we can find out the end correction E is equal to L2 minus 3L1 by 2 by taking this end correction and the values. Thank you. So here, when the tuning fork taken to the mouth of the tube, then means when the tuning fork taken to mouth of the tube, the tuning fork created the vibrations, moved into the air column. Due to the reflection of the water level, it comes to the whenever it and node is formed, then it reflected towards that, and at the open end antinode is formed. Again and again by doing this, then we can hear the loud sound at a point. Then only we can get the air columns. At certain point only we can get the loud sound. Otherwise, the sound we can't hear, the least sound we can't measure at that point. At the some point of that we can hear the loud sound. So that's why we can get that air columns, length of air columns, that is L1 and L2. Otherwise, we can't get it. So by taking that values, we have the experiment in our Board of Intermediate Education also in Telangana and Andhra Pradesh. We have the experimentally also in second year. That is a resonance tube to find the velocity of a sound by using resonant operators. Here that by using this we can do it in practicals also. So just we should do this by moving this water reservoir up and downwards. We can maintain the water levels. By at some of the level we fixed the water level, then vibrate the tuning fork taken to the mouth of the tube. Then only at some point only we can hear the loud sound from the tube because of the reflection of the water level by forming the node. If the waves, air columns are reflected, and here node is formed and here the end point antinode is formed, then only we can hear the voice and we can measure the lengths of air columns. From that only we can measure the values and we can take the values by using the formulas. Thank you. Hello everyone. In previous video we have discussed about the resonance tube. Next we are going to discuss about beats. Nowadays everyone know that what are beats. Means in functions, some of parties and in the songs also we can see the DJ sounds. The maximum and minimum of sounds by in the parties and barat nowadays. So the maximum and minimum of sound whenever the two nearly equally frequencies,
means the two not equal frequencies. Nearly equal means different, slightly different frequencies are superimposed on another. We can hear the sound at a position, at a particular time, at a given time, a particular position, the maximum and minimum sound we can hear. That maximum and minimum sound when the variation of alternate variation of intensity of sound at a time, at particular position is called beats. That means to say the phenomenon of alternate variation of intensity of sound with a time, alternate variation of intensity of sound with a time at a particular position when two sounds of nearly same frequencies and amplitudes superimpose on each other is called beats. Here just see this, here one wave is moving in one direction with one pace, one wave in a white color, and another wave with a different frequency, slightly different frequency, means here is the slightly different frequency, here is the frequency, the slightly difference is there. So with a different frequency another wave is also moving in this direction, another in this direction, same direction with the slightly different frequencies and amplitude. So whenever after some time the two waves are superimposed at a point and we can hear the sound at zero time, we can hear the whenever two waves are in opposite pace, they both cancelled each other, so the zero of sound means minimum sound we can get, means silence. Two waves are collide and collapse. Then here the whenever after same time, a particular time 0.25 seconds, another thing, here the waves are superimposed and form the single wave, means we can hear the sound same intensity of sound for the two waves, that is at 0.25 seconds, then the maximum intensity of sound we can hear. After that again we can continue this one, after 50 seconds the minimum sound. Continuously if we hear the alternate variation of intensity of sound when the two nearly equal frequency amplitude waves are superimposed one on another, then that means to say that is called as beats. Nowadays we are already in movies also, the songs are, the musical instruments are played, whenever they are playing that, the drums and the music, in everything is beats is there because of minimum and maximum of sound. The alternative periodic means alternative periodically, the alternative variation of sound with a particular given time, particular time and position is called beats. Here is that whenever we listen this is a maximum and minimum, whenever the waves get the minimum sound, then from that minimum sound here is the maximum sound and there minimum sound, maximum sound and minimum sound. The one completion of maximum to the minimum is called a beat, one beat. Here if we take the two waves which is having the angular frequency, that is omega 1 is the angular frequency which is greater than the second frequency, that is omega 2, means omega 1 is greater than omega 2. With the displacements, both are having the displacement, some of the same displacements are that S1 is equal to A cos omega t and S2 is equal to A cos omega 2t. Means here the beats means when the two waves are superimposed on one another with different frequencies, we can hear the maximum and minimum. We can say that is as waxing and waning of sound. We can hear that waxing and waning of sound, waxes and wanes. So waxing and waning of sound of alternative intensity, with alternative intensity, that sound is called, when two waves are superimposed, is called beats. Here is that beats, means the phenomenon of alternative variation of intensity of sound with the time at a position when two sound waves of nearly same frequencies, nearly same, not equal, nearly same frequencies and amplitudes superimposed on each other is called beats. This beats depends on the phenomenon of interference of waves. They under the interference of phenomenon of interference of waves will act in beats position. Okay, so next here the displacements of waves are S1 is equal to A cos omega 1t, means first wave displacement, and the second equation for the second wave S2 is equal to A cos omega 2t. Here is the second wave equation. Then next, when the two waves are superimposed on one another, from the principle of superposition of waves, we can get the final equation. From that omega greater than omega 2 with same amplitude A, and displacements S1 and S2, that is S1 is equal to A cos omega t and S2 is equal to A cos omega 2t. From the principle of superposition of waves, then S is equal to S1 plus S2, means the resultant displacement which is equal to the algebraic sum of the displacements of individual waves, that is S is equal to S1 plus S2. Then S is equal to, S1 is equal to, we have the equation, that is A cos omega 1t plus S2 is equal to A cos omega 2t, A cos omega 2t. If we substitute that from the trigonometrical relation, cos alpha plus cos beta, because of it this is the same as this formula. So cos alpha plus cos beta, cos alpha plus cos beta, whenever the A taken to the out commonly, then 2 cos alpha plus beta by 2 cos alpha minus beta by 2. From that, according to this relation, if we write this equations, then S is equal to, whenever the A taken this side, then 2 cos alpha, this is denotes with alpha and this is denotes with beta. Here is this one is a beta and this one is a alpha. So cos alpha plus beta by 2 cos alpha minus beta by 2, alpha minus beta by 2, omega 1t minus omega 2t t by 2. So S is equal to 2a cos of, when the t is common, so taking outside, then omega 1 plus omega 2 by 2 into t and cos omega 2 minus omega 1 minus omega 2 into t by 2. From this relation, we have the, whenever two waves are superimposed, then the angular frequency will be, we can hear the same equation sound. Whenever two angular frequencies are added, means the maximum sound, omega 1 minus omega 2, waning of sound, waxing and waning. Then here the omega A is equal to omega 1 plus omega 2 by 2. We are assuming that. Then omega B is equal to omega 1 minus omega 2 by 2. Let's consider that one. Then S is equal to, it will becomes 2A. The waning of sound is omega 1 minus omega 2 by 2 is omega B. So that's why omega BT. And omega cos AT, cos omega AT, then it will be the omega 1 plus omega 2 by 2. Assume that the mod of omega 1 minus omega 2 is less than or equal to omega 1, means the first wave, angular frequency of first wave is more greater than the omega 1 minus omega 2. Let's assume that. Assume that, then the resultant equation with waxes and wanes with the frequency is, when the cos omega t, here is that the term cos omega bt is moved to the positive direction or in the negative direction. The maximum or minimum, the positive direction or negative direction, means either in upwards, whenever the beats will form in upwards or in downwards. When the waves are formed, downwards means when the minimum sound, upwards means maximum sound. Then here the resultant wave waxes and wanes with the frequency is 2 omega b is equal to omega 1 minus omega 2. The resultant wave waxes and wanes with the frequency of 2 omega b is equal to omega 1 minus omega 2. Then we know that from the angular frequency, omega is equal to 2 pi nu. The relation between the linear frequency and angular frequency, that is omega is equal to 2 pi nu, or we already derived that equation, the relation between the time period to the angular frequency, that is omega is equal to 2 pi by t. From the relation also we can write omega is equal to 2 pi nu. So in 2 pi nu, the beat frequency will be, whenever we substitute this one in the equation, then we can get both sides will be cancelled. The omega b will become the new beat, 2 pi new beat frequency. Then 2 pi new beat is equal to 2 into 2. Then omega 1 minus omega 2 we can cancel it the both sides. Then new beat is equal to nu 1 minus nu 1 similar to nu 2. When this is the equation for beat frequency. Once again, when two waves of slightly frequency means nearly frequency or amplitudes are superimposed on each other, the phenomenon of alternate variation of intensity of sound, alternative variation of intensity of sound when two waves are superimposed with a slightly frequency, slightly equal to both are equally frequency or amplitude, then beats, that is called as a beats, the phenomenon of alternative variation of intensity of sound with time at a particular position when two sound waves of nearly same frequencies and amplitudes superimposed on each other is called beats. Whenever we take the beats which is having that angular frequency of first beat is more than the second one, then omega 1 larger than omega 2. By the taking the equations from the principle of superposition of waves, S is equal to S1 plus S2. By applying that, then we can get that this formation will be cos alpha, the trigonometrical relation cos alpha plus cos beta. From that relation we can get 2 cos of alpha plus beta by 2, cos alpha minus beta by 2. From that relation, by the calculation we can get that 2a cos of omega 1 plus omega 2 by into t by 2, cos of omega minus omega 2 by 2 into 2. Then let the omega is considered as omega 1 plus omega 2 by 2 and omega b is equal to omega 1 minus omega 2 by 2. Then from that, if we substitute these values in the equation, then we can get s of 2a, s is equal to 2a cos omega bt, cos omega at. Let's assume that omega 1 minus omega 2 is less than, more less than or equal to omega 1. Then the resultant wave axis and bands with the frequency is 2 omega b is equal to omega 1 minus omega 2. From that relation, we can get, we know the angular frequency, the relation between the angular frequency and linear frequency omega is equal to 2 pi nu. From that, we can get the beat frequency, mu beat is equal to mu 1 similar to mu 2. So, here the beats will be formed. Then, what are the uses of beats? What are the uses of beats? Let's, when the beats are used, then the uses of beats are, here the uses of beats to determine the unknown frequency of tuning forks. How they can be find means, when if we take the unknown frequency of the tuning fork 1 and another tuning fork standard fork taken, by the taking this, the n be the tuning forks what we have taken, then that here is the A with the number of vibrations per second. The standard tuning forks frequency is n, then A be the number of tuning fork, number of vibrations per second done by the tuning fork. Here it is that this is the standard frequency of the standard tuning fork. Already we know that unknown frequency tuning fork is there and known frequency tuning fork is there. So whenever we vibrate two tuning forks, that must be unknown tuning fork. Unknown frequency of tuning fork will be maybe n plus a or n minus a. Whenever that vibrates, then by filed the one prong or some of the particles are added to the one prong, another it can be vibrated. Either if the frequency is more, frequency is not equal to the A, means the number of vibrations per second equal to A, maybe that will be the less than, means n minus A be the correct. Means whenever we taking that A beats heard per second, then unknown frequency must be n plus A or n minus A. Definitely for the unknown frequency of sound. Then here to decide the positive or negative one of the prong of the tuning fork of unknown frequency is loaded with the wax. And vibrated. Then that tuning fork doesn't do the same vibrations which is equal to A. If tuning forks sound together, then if the number of beats per second is greater than A, if the number of beats per second which is greater than A, then the unknown tuning fork value be the n minus A. If in case of the number of beats per second is less than a, then n plus a be the frequency of that unknown frequency of the tuning fork. Means when if we take the known frequency tuning fork and unknown frequency tuning fork, then when two vibrates at a point together, then we by adding the some wax, means by adding the one prong the wax to the unknown frequency of tuning fork in vibrates, if the beats per second a is greater than a, then n minus a be the unknown frequency of that unknown tuning fork. Then if less than a, then n plus a be the unknown. Like that, by hearing that, by using the beats, we can find out the determining the unknown frequency of a tuning fork. And use in music also. Music means if the music instruments are tuning the music instruments in orchestra or another thing, if the two music instruments are doesn't have any same beat frequency, then the tune can't be clear. So that's why if the two tuning forks like sitar, guitar, two guitars must be in two equal same frequency. So that's why they will tune the same beat frequency to use by using the beats. By the beats, the tuning fork will be used. And for tuning for musical instruments, and used in electronics also. Used in electronics also, and used in mines. Means like coal mines. In coal mines, when two pipes are they blow that pipe and hear the beat. In mines also, if the same sound, same frequency of sound we can get, there is no any dangerous gases are formed in the mines. If in case of for the light gases are formed, then the frequency is higher than the frequency at air, normal air. Then they detect the dangerous gases in mines by doing the difference in beats. Means if they having the two pipes, one pipe is blown at the air or in a tube, and they blow the same sound, produce the sound, means they produce the sound in air and note the beats, and the same sound beats produced in the mines. If the two frequencies are same, there is no any gases, dangerous gases inside. If in case of gas any released, then they blow the sound, that lighter gases will have the high frequency. The sound will be, beat will be high frequency, then only the dangerous gases can be detected in mines. These are the uses of beats. First, to the unknown frequency, tuning forks, and the uses in music instruments to find the tuning the musical instruments, and another one is uses in electronics and radio receivers like that, and used in mines also, in calorie mines, coal mines like that. So here is about the beats. Hello everyone. Today we are going to discuss about Doppler effect. When two bodies are in motion, due to the relative motion, if the one body creates a sound, produces sound, then the frequency and wavelength changes. Means the frequency of sound due to the relative motion changes by the whenever he is approaching the listener or moving away from the listener. That effect is called Doppler effect. That means the apparent change in frequency of sound due to relative motion between the source and listener or observer is called a Doppler effect. When we standing on the platform, railway platform, when the rail blows a horn, when it is approaching us, then we can hear the frequency of sound more and more while it is approaching. When the train is receding from us, means that is moving away from us, then we can hear the sound less, goes on decreasing, means whenever that receding we can hear the sound goes on decreasing. That means the frequency will changes when the distance is changing, means wavelength is changing. So that here we are going to discuss about that the change in apparent frequency or apparent wavelength. How do we find out what is the derivation for an expression for an apparent frequency? By observing apparent wavelength. Then here when the S means by the source, consider a source traveling towards an observer. Here that source is in motion and observer is at rest. Then if the source is moving towards an observer, at the initial stage O means observer, S means source. At initial stage both are at a distance of wavelength is lambda is equal to Vt. Here is that when the source is released one wave, produced sound, and that sound frequency released by observer, that is lambda is equal to Vt be the wavelength. Then here the actual frequency, the frequency of sound, then nu is equal to V by lambda. Nu is equal to V by lambda. From the equation we can get that lambda is equal to V by nu, that is equal to Vt, because of nu means the reciprocal of time period is called as frequency. From that equation we can write that Vt. Then here is that lambda means SO. Here is that SO is equal to lambda, SO is equal to V into T. SO is equal to V into T. This is the equation number 1. SO is equal to V into T. Whenever the source travels towards the observer at a distance of wavelength lambda Vst, at a distance Vst, then the distance traveled by source S2 S dash is S dash is equal to Vst. All we know that the distance is equal to velocity into time. Velocity means whenever the source moves, so a Vs is equal as source velocity. Then T means time that taken to travel. Then S dash is equal to Vst. This is equation number 2. Consider it's equation number 2. Then when after reaching the point of S dash, the source created another wave that reaches the time, the apparent wavelength is lambda dash. The apparent wavelength lambda dash means here S dash O is lambda dash, that is S dash O, that is equal to, here is that S dash O is equal to SO minus SS dash, we can write that. So that's why SO minus SS dash. All we know that S dash O is equal to lambda dash, that is the apparent wavelength, that is equal to SO means already from the equation 1 Vt minus SS dash means Vst from equations 1 and 2. From equations 1 and 2. Then here is that lambda dash is equal to, all we know that V minus Vs into T. T is the same in two components, so that's why we are taking outside. Then we can get V minus Vs into T. From that equation, the apparent wavelength lambda dash is equal to V minus Vs by nu, because of since nu is equal to 1 by T, or T is equal to 1 by nu. Also we can write that from the reciprocal of frequency is called as time period. From that we can write it. Then the apparent frequency is nu dash. Nu dash is equal to V by lambda dash, means the velocity of the sound by apparent wavelength. Then we can get it V by lambda dash means V minus Vs by nu. From that nu dash is equal to V by V minus Vs into nu. Here is that the nu dash means apparent frequency and nu be the actual frequency, so that we can write that the apparent frequency is greater than actual frequency whenever the source moving towards an observer. When source approaching observer. here is that this is called a Doppler effect. This from using this formula we can find it out the apparent frequency of sound when the source is moving towards an observer or listener. Then whenever source is if the source is receding from the observer, so when the source is receding from an observer means moving away from an observer, then source moving from an observer then here when the source is at rest, source is at this point and the observer is at this point, whenever the produces one wave, then the wavelength will be lambda is equal to Vt. When source is moving away from this side means it travels S dash from point S to S dash, the length Vst. Then the apparent wavelength will be lambda dash. Then here it is that the S means source and O is the observer is at rest, so V naught is equal to 0, then we are not supporting that one. Then Vs be the source velocity, here Vs be the source velocity. From this question, whenever he creates at the position of initial stage, the source emits one crest or emits one wave, then the distance of lambda wavelength, the wavelength of lambda he recedes, so that's why the wavelength of the wave at the position, the wavelength from SO is equal to, the wavelength SO is equal to V into T, that is SO is equal to lambda is equal to V into T, that is the initial stage. Then here is that the wavelength after traveling from the S point to the S dash, the source traveled away from S to S dash, then S dash is equal to VST. Here VST means the time taken at a time t, in time t, then S dash is equal to VST. Then from that we can write that whenever the source is moving away from an observer, then we can find out the apparent wavelength, lambda dash is equal to apparent wavelength lambda dash. Here that is S dash is equal to lambda dash is equal to SO plus S dash. This will be the to find out the apparent wavelength. From this equation we can find it out. Then lambda dash is equal to, already we know that what is SO is equal to V into T plus S dash means that VST, V suffix st, VST means the source velocity into T, that is lambda dash is equal to V plus Vs into T, but we know that T is equal to 1 by mu, means the reciprocal of frequency is called time. From this we can write that lambda dash is equal to V plus Vs by nu, Vs by V plus E. This is called apparent wavelength. This is apparent wavelength. Next, by using this, if what is apparent frequency? Apparent frequency, nu dash is equal to V by lambda dash. Nu dash is equal to V by lambda dash. From that, nu dash is equal to V by lambda dash means the apparent wavelength lambda dash is equal to V plus Vs by nu. So V plus Vs by nu, that is equal to V by V plus Vs into nu. Here we can write that this is the apparent equation for an apparent frequency when the source is receding from an observer. Here is that nu dash is equal to V by V plus Vs into nu, means nu dash is less than nu. That means to say here the apparent wave frequency, is less than actual frequency. Less than actual frequency. Before, when source moving away from an observer, moving away from an observer. Here once again, here whenever the source moving from an observer, moving away from an observer, then here S be the position of source, O be the position of an observer. When the distance of wavelength of lambda, whenever the source produces the first wave, and if a source moves to away from the observer from S to S dash, then the traveled distance is Vst. Then the observer receives the wave. The wavelength is apparent wavelength, that is lambda dash is equal to. So here is the wavelength whenever from the initial position, the lambda is equal to SO is equal to lambda is equal to V into T. And after that, the source traveled away from the distance from S point to the S dash in time T, then S dash is equal to Vst. From that, here the apparent wavelength is lambda dash. Lambda dash means S dash is equal to lambda dash, that is equal to SO plus S dash, because of we want to know that the distance of apparent frequency. Here is the apparent frequency from the S dash to O. So that's why here S dash to O distance is lambda dash. S dash to O is apparent wavelength. Lambda dash is equal to SO plus S dash. SO plus S dash. So that's why we are writing that lambda dash is equal to V into T plus Vst. If we are taking common in both sides, so V plus Vs into T, then T is the reciprocal of frequency is called time period. So that's why we are substituting that 1 by nu in the equation. Then we can get the equation for an apparent wavelength, that is lambda dash is equal to V plus Vs by V nu. Then from that, apparent frequency formula is nu dash is equal to V by lambda dash. Nu dash is equal to V by, we know the apparent wavelength, the lambda dash is equal to V plus Vs by mu, that is we are substituting. Then finally we can get the equation for when the source is moving away from an observer. Here is the apparent frequency is less than the actual frequency when the source is moving away from an observer. Thank you. Hello everyone. In previous video, we discussed about Doppler's effect when the source is in motion and the observer is at rest. When the source is in means Doppler effect means the apparent change in frequency due to relative motion between the source and observer. Means when the source is in motion, is observer at rest. When the source or observer, whatever, if the observer is in motion, source at rest, then the apparent change in frequency means whenever the one source or observer move towards one another, means when the two source moving together towards, then the apparent frequency increases. Then whenever they moving away from one another, then the apparent frequency decreases than the actual frequency of sound. The change in the difference in frequency of sound to the apparent frequency of sound is called Doppler's shift. Means here when source and observer approaching each other, then the apparent frequency is greater than the actual frequency. If the observer and source are moving away from one another, then the apparent frequency is lower than the actual frequency. Then the difference between the actual frequency of sound and the apparent frequency of sound is called Doppler's shift. Doppler's shift. Then here Doppler shift means delta V, the change difference in frequency is equal to nu naught similar to nu, means the actual frequency to the apparent frequency are both difference between them. In this case, now we are going to discuss, in previous video we discussed about that source is in motion, observer is at rest. Now we are going to discuss about source is at rest and a listener is in motion, means listener in motion, source is at rest. When observer is moving towards the source, the observer moving towards the source, then here the observer is there, he is having that v naught velocity, when the listener having that v naught velocity, that is v naught. And here is that source is at rest, so that's why Vs is equal to 0, means source velocity is equal to 0. Then here when he moves towards the point O dash, it moves towards the point O dash with respect to it's by source, when he is at point O, the observer is at point O, he emits he produces one wave, then its frequency nu is equal to V by lambda. Nu is equal to V by lambda. Means here the frequency nu means the actual frequency, because of they are both sum of the distance. Source releases one crust or one wave, produced one wave and received by an observer at point O. So that's why it is moving with the normal velocity of normal frequency per second is the nu is equal to V by lambda. When observer moving towards the source to the certain distance, then it is having that another wave is produced and observed by the source per second is here that the frequency will be nu dash is equal to V naught by lambda, because of he is moving with velocity V naught. He is moving with velocity V naught. At point O dash, at point O dash, the observer receives more frequency than at point O. So that's why here the source, when the source number of waves produced by the source per second is nu, means the frequency is nu. When the point S is stationary and at the same t is equal to 0, that at a time the observer received velocity will be, the frequency will be nu dash. Means the number of waves produced by source in 1 second is nu with the normal actual frequency nu. By the observer received by the observer, that second is nu naught. So that's why then apparent frequency nu double dash is equal to the number of waves produced by the source and the number of waves received by the source. Whenever the observer moving towards the source, then he receives more frequency of sound by each second in addition with the receiver's velocity, observer's velocity frequency. Means he is moving and he is receiving the more and more waves in addition to this normal frequency. Means at the same V is equal to V by lambda. In addition to this, nu is equal to V by lambda. In addition to this nu by lambda, he is receiving that more frequency, means nu dash is equal to V naught by lambda. Because of he is moving with V naught velocity, he is receiving more frequency of waves. So that's why we can say that when the apparent frequency, which is equal to number of waves produced by the source plus number of waves produced by the source plus the number of waves received by an observer, that is nu dash is equal to V naught by lambda. In case of the source is at rest, produces one wave and nu is equal to V by lambda, that source frequency. Then whenever he is moving, he is receiving more waves because of he is moving towards an observer, towards the source. Then he is receiving more than the normal frequency in addition to this normal frequency of sound, that is nu plus nu dash. That means to say apparent frequency, which is equal to number of waves produced by the source, plus number of waves received by the observer. So here is that the number of waves when the source is stationary. In addition to this, here apparent frequency nu dash is equal to number of waves produced by the source plus number of waves received by an observer. That means to say here number of waves produced by the source is nu and the number of waves received by the source is nu dash. Number of waves is by the observer is nu dash. Here the apparent frequency nu double dash is equal to number of waves produced by the source nu plus number of waves received by an observer is nu dash. Then the number of waves produced nu is equal to V by lambda with the normal frequency of sound is whenever the stationary is at rest and observer is at a distance at the initial point at O. initial point at O, he received the first wave, that is a nu with the normal frequency of sound is nu is equal to V by lambda. After, when he is moving towards the source, then number of waves received by observer per second is a nu dash is equal to V naught by lambda. Means whenever he moving towards the source at a distance of O dash, the point to the O dash, then he receives the number of waves in per second frequency is nu dash is equal to V naught by lambda. V naught be the observer's velocity and the lambda is the wavelength. Then here the apparent frequency is a nu double dash, means the observer received more frequency than the initial point when he moving towards the source. Then at a point O dash, while he is moving, he receives more frequency. So that's why we are adding when the number of waves per second in addition to the number of waves received by an observer is nu dash. That apparent frequency is nu double dash is equal to, then nu plus nu dash, means here nu is the number of waves produced by the source, plus nu dash means the number of waves received by an observer. So that's why nu plus nu dash, then we can get nu dash double dash is equal to nu means V by lambda, then the number of waves received by an observer per second, nu dash is equal to V naught by lambda. We are substituting these two values in the equation. Then we can get, by doing LCM, we can do V plus V naught by lambda from that, but we know that from the equation nu is equal to V by lambda, we can write that the lambda is equal to V by nu by the normal wavelength, for the normal wavelength. So that's why nu double dash is equal to V plus V naught by, we are substituting lambda is equal to V by nu in the denominator, then V by nu. Then here the V by nu means the apparent frequency nu double dash is equal to that nu is the denominator for denominator. So that's why it can move into the numerator. So that's why V plus V naught by V into nu, V plus V naught by V into nu. Here also we can write this equation, nu double dash is equal to 1 plus V naught by V into nu, 1 plus V naught by V into nu. Then from this apparent frequency, so that's why we can say that here nu double dash is equal to V plus V naught by V into nu, means the actual frequency whenever we multiplied with V plus V naught by V, then only which is equal to the apparent frequency, because of the observer received more number of frequency of sounds than the initial point. So that's why we can say that nu double dash is equal to V plus V naught by V into nu. So that's why apparent frequency is more than the actual frequency, though nu double dash is greater than is equal to nu. When if the observer is moving away from the source, he absorbs less frequency of sounds. Here is that whenever if in case of he is moving away from the source, then he receives less than the actual frequency of sound. So that's why he is losing some. So that's why the wave total apparent frequency will be less. Then the number of waves produced by the source in subtraction means subtracted with the number of waves received by the observer, means the observer's frequency will be minus, means less. So that's why we can say that from that equation we can go through that apparent frequency nu double dash is equal to that V naught, means the observer's velocity will be negative. So that's why V minus V naught by V, because of he is losing some frequency of sounds. He cannot hear, the volume of the sound, speed of a sound will be going on decreasing, the frequency of going on decreasing. So that's why V minus V naught by V into nu. Here is that whenever the actual frequency of sound which is less than the apparent frequency is less than the actual frequency. So that's why apparent frequency is lower than actual frequency. From that nu double dash is equal to less than, nu double dash is less than nu. Means apparent frequency of sound is lower than the actual frequency. This is about when the listener is in motion, source at rest. When the observer or listener is moving towards the source or moving away from the source, we can find the apparent frequency by using these equations. This is about Doppler's effect when the Doppler shift means the difference in frequency of sound to the and the apparent frequency of sound is called Doppler shift. When the listener is in motion, source is at rest, then we can find the values of apparent frequency expression. These are the expressions for apparent frequency. This one is for when the source is moving towards an observer and observer is moving towards the source. Then this is one is when the observer is moving away from the source. This one is. Hello everyone. In previous video we discussed about Doppler's effect when the source is in motion and observer is at rest. When the source is in means Doppler effect means the apparent change in frequency due to relative motion between the source and observer. Means when the source is in motion, is observer at rest. When the source or observer, whatever, if the observer is in motion, source at rest, then the apparent change in frequency means whenever the one source or observer move towards one another, means when the two source moving together towards, then the apparent frequency increases. Then whenever they moving away from one another, then the apparent frequency decreases than the actual frequency of sound. The change in the difference in frequency of sound to the apparent frequency of sound is called Doppler's shift. Means here when source and observer approaching each other, then the apparent frequency is greater than the actual frequency. If the observer and source are moving away from one another, then the apparent frequency is lower than the actual frequency. Then the difference between the actual frequency of sound and the apparent frequency of sound is called Doppler's shift. Doppler's shift. Then here Doppler shift means delta V, the change difference in frequency is equal to nu naught similar to nu, means the actual frequency to the apparent frequency are both difference between them. In this case, now we are going to discuss, in previous video we discussed about that source is in motion, observer is at rest. Now we are going to discuss about source is at rest and a listener is in motion, means listener in motion, source is at rest. When observer is moving towards the source, the observer moving towards the source, then here the observer is there, he is having that V naught velocity, when the listener having that V naught velocity, that is V naught, and here is that source is at rest, so that's why Vs is equal to 0, means source velocity is equal to 0. Then here when he moves towards the point O dash, it moves towards the point O dash with respect to its by source, when he is at point O, the observer is at point O, he emits he produces one wave, then its frequency nu is equal to V by lambda. Nu is equal to V by lambda, means here the frequency nu means the actual frequency, because of they are both some of the distance, source releases one crust or one wave, produced one wave and received by an observer at point O, so that's why it is moving with the normal velocity of normal frequency per second is the nu is equal to V by lambda. When observer moving towards the source to the certain distance, then it is having that another wave is produced and observed by the source per second is here that the frequency will be nu dash is equal to V naught by lambda, because of he is moving with velocity V naught. He is moving with velocity V naught. At point O dash, at point O dash, the observer receives more frequency than at point O. So that's why here the source, when the source number of waves produced by the source per second is a nu, means the frequency is nu. When the point S is stationary and at the same t is equal to 0, that at a time the observer received velocity will be, the frequency will be nu dash. Means the number of waves produced by source in 1 second is nu with the normal actual frequency nu. By the observer received by the observer, that second is a nu naught. So that's why then apparent frequency nu double dash is equal to the number of waves produced by the source and the number of waves received by the source. Whenever the observer moving towards the source, then he receives more frequency of sound by each second in addition with the receiver's velocity, observer's velocity frequency. Means he is moving and he is receiving the more and more waves in addition to this normal frequency. Means at the same V is equal to V by lambda. In addition to this, nu is equal to V by lambda. In addition to this nu by lambda, he is receiving that more frequency, means nu dash is equal to V naught by lambda. Because of he is moving with V naught velocity, he is receiving more frequency of waves. So that's why we can say that when the apparent frequency, which is equal to number of waves produced by the source plus number of waves produced by the source plus the number of waves received by an observer, that is nu dash is equal to V naught by lambda. In case of the source is at rest, produces one wave and nu is equal to V by lambda, that source frequency. Then whenever he is moving, he is receiving more waves because of he is moving towards an observer, towards the source. Then he is receiving more than the normal frequency in addition to this normal frequency of sound, that is nu plus nu dash. That means to say apparent frequency, which is equal to number of waves produced by the source, plus number of waves received by the observer. So here is that the number of waves when the source is stationary. In addition to this, here apparent frequency nu dash is equal to number of waves produced by the source plus number of waves received by an observer. That means to say here number of waves produced by the source is nu and the number of waves received by the source is nu dash. Number of waves is received by the observer is nu dash. Here the apparent frequency nu double dash is equal to number of waves produced by the source nu plus number of waves received by an observer is nu dash. Then the number of waves produced nu is equal to V by lambda with the normal frequency of sound is whenever the stationary is at rest and observer is at a distance at the initial point at O. He received the first wave, that is a nu with the normal frequency of sound is nu is equal to V by lambda. After when he is moving towards the source, then number of waves received by observer per second is nu dash is equal to V naught by lambda. Means whenever he moving towards the source at a distance of O dash, the point to the O dash, then he receives the number of waves in per second frequency is nu dash is equal to V naught by lambda. V naught be the observer's velocity and the lambda is the wavelength. Then here the apparent frequency is nu double dash, means the observer received more frequency than the initial point when he moving towards the source. Then at a point O dash, while he is moving, he receives more frequency. So that's why we are adding when the number of waves per second in addition to the number of waves received by an observer is nu dash. That apparent frequency is nu double dash is equal to then nu plus nu dash, means here nu is the number of waves produced by the source plus nu dash means the number of waves received by an observer. So that's why nu plus nu dash, then we can get nu dash double dash is equal to nu means V by lambda, then the number of waves received by an observer per second nu dash is equal to v naught by lambda. We are substituting these two values in the equation. Then we can get, by doing LCM, we can do v plus v naught by lambda. From that, but we know that from the equation v is equal, nu is equal to v by lambda, we can write that the lambda is equal to v by nu by the normal wavelength, for the normal wavelength. So that's why nu double dash is equal to v plus v naught by, we are substituting lambda is equal to v by nu in the denominator, then v by nu, then here the v by nu means the apparent frequency nu double dash is equal to that nu is the denominator for denominator. So that's why it can move into the numerator. So that's why v plus v naught by v into nu, v plus v naught by v into nu. Here also we can write this equation, nu double dash is equal to 1 plus v naught by v into nu, 1 plus v naught by v into nu. Then from this apparent frequency, so that's why we can say that here nu double dash is equal to v plus v naught by v into nu, means the actual frequency, whenever we multiplied with v plus v naught by v, then only which is equal to the apparent frequency, because of the observer received more number of frequency of sounds than the initial point. So that's why we can say that nu double dash is equal to v plus v naught by v into nu. So that's why apparent frequency is more than the actual frequency, though nu double dash is greater than is equal to nu. When if the observer is moving away from the source, he absorbs less frequency of sounds. Here is that whenever, if in case of he is moving away from the source, then he receives less than the actual frequency of sound. So that's why he is losing some. So that's why the wave total apparent frequency will be less. Then the number of waves produced by the source in subtraction means subtracted with the number of waves received by the observer, means the observer's frequency will be minus, means less. So that's why we can say that from that equation we can go through that apparent frequency nu double dash is equal to that v naught, means the observer's velocity will be negative. So that's why v minus v naught by v, because of he is losing some frequency of sounds. He cannot hear, the volume of the sound, speed of a sound will be going on decreasing, the frequency of going on decreasing. So that's why v minus v naught by v into nu. Here is that whenever the actual frequency of sound which is less than the apparent frequency, apparent frequency is less than the actual frequency. So that's why apparent frequency is lower than actual frequency. From that nu double dash is equal to less than, nu double dash is less than nu, means apparent frequency of sound is lower than the actual frequency. This is about when the listener is in motion, source at rest, when the observer or listener is moving towards the source or moving away from the source, we can find the apparent frequency by using these equations. This is about Doppler's effect. When the Doppler shift means the difference in frequency of sound to the and the apparent frequency of sound is called Doppler shift. When the listener is in motion, source is at rest, then we can find the values of apparent frequency expression. These are the expressions for apparent frequency. This one is for when the source is moving towards an observer and observer is moving towards the source. Then this is one is when the observer is moving away from the source. If the source is in rest and observer is in motion, just now we have derived an equation, that is when if the source is at rest, observer in motion, then according to the time period, then we can do that when moving away from observer moving away from the source. Away from the source. Means, just now, in this case, source is at rest, observer is in motion. For method 2, according to the time period, we can derive the equation, that is method 2. Method 2 means source is at position at S, is at rest. So the source velocity Vs is equal to 0. Then observer is at a distance of L from the source. Observer at a distance of L from the source. When the source is at a distance of L, source and observer both are at a certain distance. Whenever observer is moving away from the source at a point to the O dash, he is moving with velocity V0. V0 means observer's velocity. So here is the observer's velocity V0, that is he travelled at a distance of V0 T0. V0 T0, distance is equal to velocity into time. So V0 T0 means V means observer's velocity V0, and T0 means the time taken to travel from this point to that point, that is T0. So here is that, consider here the source and observer, observer at a distance L, and here is that at a time t is equal to 0, the source has produced one wave, that is the first wave. The time taken by the observer to receive, that is T1. T1 is equal to L by total distance L by from this point to this point. Whenever observer is at this point, he received first wave, that is L by. The distance will be the L and the velocity will be when the source is at rest, but the total velocity of sound will be V. Is the sound is moving with same velocity, then that is V plus V0. V plus V0, because observer is also in motion with the velocity V0, so that's why L by total velocity will be V plus V0. And if in case of after some time observer travelled certain distance in time T0, T is equal to T0, observer travelled some distance, that is V0 T0, distance is equal to, distance will be total length L plus distance travelled V0 to T0, so L plus V0 T0 be the distance that the observers travelled. So after some time he received another wave, that the distance L plus V0 T0, then the second wave has received by the observer, that is T2 is equal to T0 be the time taken to travelled by an observer from O to O dash, plus the time taken to receive the observer, that is L plus V0 T0 by V plus V0. Then after travelling some time, T is equal to 2T0 time, then the third wave as received by an observer, that is T3 is equal to 2T0 plus L plus 2V0 T0 by V plus V0. Means here the L plus V0 T0 by V plus V0 is the distance by the travelled by the wave. Means at the starting from S to the total distance travelled L plus V plus V0 plus T0, L plus V0 plus T0, L plus V0 T0. So that's why L plus V0 T0 distance travelled by the wave. So the time taken to travel the observer plus the time received by an observer from the L point to the reached point O dash, L plus V0 T0 by V plus V0. Then this is the third wave after travelling sometime 2 T0, means here is the O double dash, it is 2 T0, means here is the 2 V0 T0. Okay, then the total distance has travelled. So we are writing that for n times the observer n distance travelled, so that's why n T0 will be that. Then whenever after travelling n times n T0 distance, then the crust received by the observer is n plus 1th wave. N plus 1th wave has received by an observer after traveling n t naught times. So here Tn plus 1 is equal to n t naught plus L plus n V naught T naught by V plus V naught. Further, the total time taken to receive the waves by an observer is the time t is equal to Tn plus 1 minus T1. Tn plus 1 minus T1. Then a time period capital T is equal to small t by n, that is equal to Tn plus 1 minus T1 by n. Here is that the total value begin. Then the time period t is equal to, what is Tn plus 1? Tn plus 1 means n t naught plus L plus n V naught T naught by V plus V naught, means n t naught plus L plus n V naught T naught by V plus V naught minus what is T1? T1 is equal to L by V plus V naught. So L by V plus V naught. From that equation then we can write that here is the denominator taken separately to the L and N plus V naught T naught, then we can get N T naught plus L by V plus V naught plus N V naught T naught by V plus V naught minus L by V plus V naught. Here is that we are writing the denominator to the L and N V naught T naught separately, then we can get the equation. Then from that equation we can write that the L plus L by V plus V naught minus L by V plus V naught get cancelled. Then from that T is equal to N T naught plus, in the both terms N T naught is common, so we are taking outside, then N T naught, then 1 plus n t naught taken outside, so that's why that remaining V naught by V plus V naught, V naught by V plus V naught. So here if we compared with the velocity of an sound of a observer's velocity, the observer velocity is very small, which can be negligible. So that's why here the V naught is very less than if we compared with the velocity of a sound. So that's why V naught is less than V. So V plus V naught is equal to V. We can write that similarly equal to V. V plus V naught is equal to V. From that equation when we can write that T is equal to n T naught of 1 plus V naught by V. 1 plus V naught by V. Already we know that by n is there. By n is there in total terms. So by n is there, we are cancelling n. We are cancelling n. So here that n is there in the total terms. So we are cancelling that denominator n and numerator n, that get cancelled. Then T is equal to T naught of 1 plus V naught by V. Then from that, but apparent frequency nu is equal to 1 by T. Here nu is the apparent frequency. Then from that here nu is equal to 1 by T, then nu is equal to 1 by T means 1 by T naught, 1 by T naught plus T naught of 1 plus V naught by V. V naught by V. We know that 1 by T naught is equal to same as nu is equal to 1 by T. Like that mu naught is equal to also 1 by T naught. So we can write that nu is equal to nu naught of 1 plus V naught by V. 1 plus V naught by V. Here is that 1V inverse, because of whenever taken to the numerator, the denominator taken to the numerator, inverse sign will get. So that's why from binomial principle, from binomial principle we can get that 1 plus x power n is equal to 1 plus nx. If we compare with this 1 plus v naught by v whole power minus 1, with this, then we can get the equation is from 1 plus x power n is equal to 1 plus nx, we can get the equation is here nu is equal to nu naught of means 1 here plus minus 1 into plus minus in this position x position v naught by v is there, so that's why we are writing that v naught by v. This is the equation for when the source is at rest and observer is in motion towards the source, then we can get the equation here is that nu is equal to nu naught of 1 minus v naught by v. Means whenever the observer is moving away from the source, not towards, away from the source. When observer away from the source, if in case of if the observer moving towards the source, then if observer moving or approaching the source or approaching the source, v naught becomes minus v naught becomes minus v naught. So here is that if we write that minus nu is equal to nu naught of 1 plus v naught by v. Here is the equation for an apparent frequency of whenever the source is here moving towards the observer is nu is equal to nu naught of 1 plus v by v. If in case of source is observer is moving away from the source, then we can get the equation nu is equal to nu naught of 1 minus v by v. Here is that about that Doppler effect when the source is in motion, source is at rest and observer is in a motion. Hello everyone. In previous video we have discussed about Doppler effect when the source is in motion, observer is at rest. In case of source moving towards an observer and away from the observer, as well as the observer is in motion and source is at rest when the observer moving towards the source and away from the source. The equations for the apparent wavelength and apparent frequency we have derived. Next, and also method 1 and method 2 also we have discussed earlier. In old textbooks we have the method number 1 and for the new textbooks we have method number 2. Now today we are going to discuss about that when the both means source and observer both are in motion. And the source and observer both are in motion. If in case of when the source and observer both are in motion, when that medium is at constant, medium taken as constant, then we can get it both source and observer is in motion when the moving in the same direction, means when the observer is moving on the one direction, the source is following the observer, then means the both source and observer are moving in the same direction, because of source is moving, so that's why we have that source velocity Vs. And observer is also moving in this direction, so that's why we are taking that v naught be the observer's velocity. Then the apparent wavelength, all we know that lambda dash is the apparent wavelength is equal to, then wavelength is equal to v by nu, means velocity by frequency. So that's why velocity will be here v minus vs be the velocity and by nu is the frequency, means whenever the lambda dash means apparent wavelength lambda dash is equal to v minus vs by nu, means frequency. Then if in case of apparent frequency, then we can get nu dash is equal to v minus v naught by v minus vs into nu be the formula for when the both source and observer are moving in the same direction, either source following the observer, means source behind the observer. If in case of source is moving forward and observer is following, means observer is behind the source, then here we can get that here the observer's direction is changes. Observer direction changes. So here it is when observer behind the source means source is traveling in this direction and observer is traveling in this direction means observer is behind the source. Then we can get apparent wavelength lambda dash is equal to V plus V naught by nu. Then the apparent frequency will be nu dash is equal to V plus V naught by V minus Vs into nu. Nu be the actual frequency and nu dash be the apparent frequency here. Nu plus V naught by V minus Vs into nu means nu dash is the apparent frequency, nu is the actual frequency. Here then next, when both are moving each other means when the source and observer are moving towards to each other. Moving towards to each other means the distance wavelength is decreasing between the source and observer. Then we can get that when the source is moving in this direction with velocity source velocity Vs and observer is also moving in this opposite to the means both are opposite to each other moving towards each other, that is V naught with the observer's velocity V naught. Then the apparent wavelength will be lambda dash is equal to V minus Vs by nu. V minus Vs by nu. Then here the apparent frequency will be nu dash is equal to V plus V naught by V minus Vs into nu. V plus V naught by V minus Vs into nu. Then this will be the equation for when apparent frequency when the source and observer moving towards to each other means meeting each other, then the more frequency can get by the observer than the whenever if the source and observer are moving away from each other, then we can get it when the source is moving in this direction, that is Vs with velocity Vs, then observer is also moving in this opposite direction to the source, then V naught be the observer's velocity, then the apparent wavelength lambda dash is equal to V plus Vs by nu, V plus Vs by nu, then the apparent frequency nu dash is equal to V minus Va naught by V plus Vs into nu. Then here is that then we can follow that whenever the observer or source in motion, how we get that equation directly. If we want to confirm that the equation we have derived is perfect or not, then the general equation for apparent frequency of a wave when the both source is in motion or observer is at rest or observer is in motion source at rest, if the both are is in motion, these are the general expression for the apparent frequency. Next now we know the what is the general expression for the apparent frequency of a wave. The general expression for the Doppler effect in all the cases when the source is at rest and observer is in motion or observer is at rest, source is in motion, whatever when the both source and observer are in motion, both are is in motion, then we can derive the equations directly by using this equation for apparent frequency. So here is that in all the cases by applying the sign convention means when the direction of the sound taken as a reference, then by the taking the sound as a reference, direction of sound of reference, if the sign convention is applied in the equation, then we can find the equation easily. So here is that all the cases of Doppler effect can be obtained from the general expression by applying sign convention. The general expression is nu dash is equal to V minus V naught by V minus Vs into nu. Means here the V is the velocity of sound and V naught be the observer velocity, and here is Vs is the source velocity, nu be the actual frequency, and nu dash be the apparent frequency. So by following the sign convention, when the direction of the sound is taken in a taken as a reference, then we can find the equation. Then the equation for an apparent frequency, if source and observer's velocities are both are in the same direction as that of the sound direction, means here the sound direction is in this direction and also observer's direction is also in this direction, means V naught and Vs. Then we can take it as a positive Vs plus Vs plus V naught to substitute in the equation. Means same as it is equation we can get because of minus of plus minus, minus of plus minus. So V minus V naught by V minus Vs whenever the both are in having the same direction. Means in case of just now we have derived an equation whenever the source is behind an observer, then we have derived an equation that is when V minus V naught by V minus Vs. Means if in case of source is moving in this direction, that is positive Vs, because of sound is also in this direction, and this is the source and this is observer, the observer's velocity is also in the same direction, then both can be taken as positive. So that's why we are applying this one, V minus of plus V naught, then V minus of plus Vs, then we can get V minus V naught by V minus Vs into nu. That will be the equation for when the both source and observer is moving in the same direction, when the source behind an observer. If in case always sound travel towards the direction of the observer, as we know that. So if in case of both are in opposite direction, means the observer is behind the source. This is the observer, positive V naught, sorry, minus V naught, and the source is moving, the sound is moving in this direction, then minus Vs. Then we can get from the equation. So V plus V naught by V plus Vs. Means here is minus of minus V naught, because of sound always moving towards the direction of an observer, because the observer receiving the frequency. So that's why here is the direction of V, here is also direction of V, velocity of sound. So when the sound is absorbed by an observer, the observer's velocity is in opposite direction to the velocity of a sound, then the source's velocity is also opposite direction to the velocity of sound. So that's why it is taken as a minus Vs. Observer's velocity is also taken as a minus V naught. So minus of minus V naught, minus of minus Vs. Then we can get that V plus V naught by V plus Vs, as whenever we have derived equation, that is when observer behind the source. Observer behind the source, that is V plus V naught by V plus Vs, as we know that. Then next, if in case of when the source is in motion, observer is at rest. Source is in motion, observer is at rest. Means the source is in motion, Vs means whenever source is moving towards an observer and observer is at rest, V naught is equal to 0. Then it is moving towards an observer, that is plus Vs. As V naught is equal to 0, then we can get nu dash is equal to, when V minus V naught is equal to V minus 0 by V minus of plus Vs. So here is that V minus Vs into nu. This is the equation for when the source moving towards the stationary observer. If in case of away from, when the source is moving away from, their sign will become minus Vs. Then means the sound velocity is in this direction, then the velocity of source is in opposite direction to the velocity of sound, then the velocity of source is negative, taken as a negative. So here is that whenever minus of minus Vs becomes plus Vs, when the source is moving away from the stationary observer, then we can get that apparent frequency nu dash is equal to V by V plus Vs. Here is that, and again we can, in all the cases we can derive an equation when the air is at constant, means medium is at constant. We should follow that one, medium is at a constant. Medium is at constant, whenever we take in that medium is at constant, then we can, all the cases we can derive the equations by using this general expression for a Doppler effect in all the cases by applying sign convention. Here is that if opposite direction of a sound taken as a negative, already we just now applied, then easily we can find it out that in 10th class, means in 10th standard we have the diagram for trigonometrical, that is all silver teacups type of diagram, all silver teacups. All silver teacups diagram. When the source taken as primary first one, then observer taken as the next one. When the source first one, after that observer taken as next one, here is the whenever the source or observer is moving in this direction, means this is the positive x-axis, this is side where we can get the negative values of x-axis. So that's why we are taking that this is negative x-axis, this is positive x-axis. Then if the source or observer, whatever it is, if the moving in this direction means positive side, then that values can be taken as a plus Vs plus V naught, means a positive direction. If in case of both source velocity or observer's velocity, means in the direction of negative x-axis, then it is taken as minus Vs minus V naught. Here is the one of the trick. Then we can follow the, if we take the sound direction as a reference, then easily we can, whatever the take in the direction is there, we can find out the values easily. So we should take first the sound as the direction of sound as a reference, then we can get easily. If the sound is moving in some of the direction, means this is the direction of the sound, here is the source or observer, whatever, then source observer I am taking. Then here is the direction depends on the equation by applying sign convention, means if in case of this is the positive, this is positive, either they are moving in the negative, this is negative, either it is moving minus negative, means negative means it is positive Vs, positive V naught, negative V naught, positive Vs, minus Vs, means by total depends on this sign convention. By using this general equation, we can find it out the apparent frequency of a wave in all the cases by using this sign convention. Hello everyone, in previous video we discussed about the Doppler effect when the both source and observer is in motion. Either observer is behind the source or the source is behind the observer. Whenever the observer and the source are moving towards to each other and moving away from each other, we have discussed the apparent frequency of sound equations, and as well as how to find the general expression. By using the general expression, how to find the apparent frequency by applying the sign conventions with the reference of direction of speed of a sound. By taking the speed of a sound as a reference, then we can find it out that when the direction, if the direction of the source and the direction of the observer is in the same direction of speed of a sound taken as positive. Otherwise, if the source or the observer's velocities are opposite to the direction of the velocity of a sound taken as a negative, by applying that sign convention, we can derive the equations for apparent frequency in all the cases by the equations of a general expression of a Doppler effect. Then now we are going to discuss about that what are the limitations, means if the source and observer are in some of the motion, in all the cases it is Doppler effect can be possible or not. The limitations, what are the limitations of Doppler effect, we are going to know. That first, when the velocity of a sound, means then the velocity of a sound of a source or velocities, means the velocity of source or velocity of observer is more than the velocity of a sound, then there is the Doppler effect is not applicable. Means Doppler effect cannot be applicable if the source velocity or observer's velocity is more than the sound velocity of a sound. Then here is that the Doppler effect is not valid when the source velocity and observer's velocity is more than the speed of a sound, that is V naught is greater than V or Vs is greater than V. Then Doppler effect is not applicable for that case. And one more thing is there, it is only under applicable, it is only under valid when the medium is in elastic condition, under the elastic conditions of the medium. Means either if the sound is traveling through the medium, then that medium has to remain its, it has to regain its original position after the time. Means it has to be the elastic condition. Whenever the medium is in elastic condition, then only the Doppler effect can be applicable. Otherwise, if that is not elastic, means inelastic the medium, that cannot be possible, because whenever the first wave is traveling through the medium, that if the medium cannot restore that elastic, it doesn't have the elastic nature, then second wave cannot be passed through that medium with the same velocity or with the same conditions of the wave. So that's why it must be the elastic condition. That Doppler effect is valid only for under the elastic condition of the medium. That is the second one. In case of if the observer is far away from the line joining of the line of the from the source, the sound cannot be heard by the observer. Means is the far away from the line of the source. In that case also, the Doppler effect cannot be applicable. Means if the observer is far away from the line of the sound of source, lines of sound of source from the source, then the Doppler effect cannot be applicable. The next one is, it is absent when source velocity or observer's velocity are perpendicular to the line joining of sound. Means if the sound is there, then to line joining source and observer. Whenever the Doppler effect is absent, when the source velocity or observer's velocity is perpendicular to the sound, line joining to the source and observer. If the both are in observers, and then we can find out that whenever these are the limitations of a Doppler effect. When the Doppler effect is not valid, when source velocity or observer's velocity is more than the speed of sound. Means V0 is greater than V or Vs is greater than V, Doppler effect is not valid. In case if it is valid under elastic conditions of medium only. Means elastic must be medium must be under the elastic conditions. It has to be in under elastic conditions only. Otherwise, the Doppler effect is not valid for inelastic conditions. Then not applicable when observer far away from the line of motion from source. If the line of motion from source, if the observer is far away, which is can't get the sound of source, then the Doppler effect is not valid, not applicable. Then the last one, it is the absent when source velocity or observer's velocity perpendicular to line joining of source and observer. Line joining of source and observer. These are the limitations of Doppler effect. These are the important one we should know. Then next, after limitations, then what is the use of Doppler effect? How do we use? What are the applications? In what ways the Doppler effect can be applied in livelihood? Means in daily life. Means the Doppler effect is used to measure or to know the position and direction and the speed of a submarine or another particles which is under the sea, they are passing by combination of sound of echo. By applying the Doppler effect with the combination of sound echo, it is used to find the position, direction and speed of submarines and other particles which are traveling under the sea, which can be known to know by using the Doppler effect with the combination of sound echo. We can find the position and direction and speed of submarines and etc. And to find the direction, speed, position of aircraft, satellites, missiles, whatever it not is moving in the sky, to know that position, direction and the speed of the particles which are traveling in the sky, means whenever flying, when some of the particles are flying in the sky, to know their position, direction and the speed of satellites, missiles, aircrafts, aeroplanes, flights, rockets, whatever. By using the radio waves, by applying Doppler effect by using the radio waves, then we can find out that the position, direction, speed of a satellites, missiles, aeroplanes, what are the elements are flying in the sky by using the radio waves. Radio waves are used to find that by applying the Doppler effect. With the reflection of sound waves, the Doppler effect will apply with the reflection of the sound waves. Then it is applied in daily life by using the traffic police, means gun, to find the speed of automobiles which are moving. Somebody is doing rash driving. The traffic police used to like gun by applying Doppler effect when the waves are moved through that one. Then due to the reflection, you can find out that what is the velocity of that automobile, what is the speed of that automobile. Then only can traffic police by applying that. Then you can get by applying microwaves, applying Doppler effect in microwaves, applying the Doppler effect. So use it by the traffic police to know the speed of automobiles. Okay, next, to guide the aircrafts which are flying in the sky, then what is the way to go? There is no any traffic signals in the sky, so that's why they guide from the airports. To guide the aircrafts from the airports in user to the Doppler effect. By applying the Doppler effect, we can find out they can guide what is the way to what the longitude and what the latitude they have to move. What the altitude they have, then in the what direction, in what the direction they have to move. By applying the Doppler effect with the aircrafts, they can they can guide from the airport. Next, in medicines, in medicals, according to the health purpose, they know what is the movement of the fetus which is in mother's womb. What is the movements? What is the heartbeat? What is the movements they can take the readings. What is they will know by using the Doppler effect what is the movement of fetus and what is the blood flow in the body, and what is the blood flow in the body. By using the Doppler effect we can measure that. These are the applications in our daily life which is used in our daily life. Not only this one, to know the binary stars and the rotations of sun, binary stars and rotations of sun, these are all measured by applying the Doppler effect. By applying the Doppler effect we can be measured. And not only that, to identify the binary stars and also to know the Saturn rings, to determine the Saturn rings and the rotational speed of sun, means by applying the Doppler effect, in this case in the medicine, to know the movement of the fetus in this blood flow, we use the ultrasonic waves. So here is the applications of Doppler effect. First one is to use to find the position, speed and direction of the submarines and also other bodies inside the sea, inside the water, by the combinations of sound echo. And next one, to find the position, direction and speed of motion of aeroplanes, missiles, satellites, what are the flying particles in the sky. And one more thing, to know that radio waves are used, to know that, and used by the traffic police to know the speed of automobiles, to reduce the rash driving, to reduce the accidents. These are the microwaves to know the speed of a sound, to know the speed of a automobile. Doppler effect is applied, and to guide the aircrafts, and as well as in medicine to know the movement of the fetus in mother's womb and also the blood flow in the body, and as well as to know the identify the binary stars, to determine the Saturn rings and the rotational speed of a sun, etc. We used the Doppler effect is used to apply it in our daily life. Thank you. Hello. So today now we are going to discuss about the 2 marks questions which we can get in public examination for Telangana and Andhra Pradesh Board of Intermediate Education. The important 2 marks problems which is added to that long answer question, because of waves unit is for the long answer question unit which contains 8 marks, 6 marks for the long answer question and remaining 2 marks for the problem which is added to that long answer question in section C. So here it is that what is the 2 marks problem? First of all, we are going to discuss about the textual problems which are weakened in the textbook. First one is estimate the speed of a sound in air at a standard temperature and pressure, which mean to say STP. At STP, the speed of a sound in air, we should find out that the speed of a sound at STP. We should estimate that one. He asked for to estimate the speed of a sound in air for at a standard temperature and pressure. The mass of 1 mole of air is 29.0 into 10 to the power of minus 3 kg, which is having the gamma value is 7/5. Already we know that gamma value in the adiabatic process. The ratio of 2 specific heats means the ratio between the specific heat of a gas at constant pressure and specific heat of a gas at constant value. The ratio between both we can get the gamma is equal to value will be the 7/5. Already in the concepts we discussed about that the speed of a sound in air is the according to the Newton's formula. After the Laplace correction, the Newton's formula becomes that V is equal to root of gamma p by rho. So first of all, what is the A as given value? First at STP, what is meant by the STP? Means at standard temperature and pressure, then what is the pressure atmosphere? Means pressure is equal to 1 atmosphere, that is equal to 1.01 into 10 to the power of 5 Newton per meter square. Is the one at STP, the pressure value will be that 1.01 into 10 to the power of 5 Newton per meter square. Then after that, what is the density which is in the air? We should calculate the density means mass by its volume. Density means mass by its volume. So we are considering that the speed of a sound in air. So that's why here we are taking the 1 mole of air. 1 mole of air means mass is the 1 mole of. So that's why mass of 1 mole of air by its volume. 1 mole of air at 1 STP means volume of a 1 mole of air at STP means at standard temperature and pressure. That means the mass of a 1 mole of air will be, he has given the problem, that is 1 mole of air is 29.0 into 10 to the power of minus 3. That is the mass of the volume, and that the volume of the, when we know that with standard pressure and temperature 22.4 liters we can contain the 1 mole of volume of a gas. So that's why here the 224 into 10 to the power of minus 3 meter cube is the value for standard at standard temperature pressure. This will be the volume of the gas, 22.4 liters of gas. Then means if we calculate this one, 10 to the power of minus 3, 10 to the power of minus get cancelled by applying by, and that one calculating we can get 1.29 kilogram per meter cube is the value for the density. Rho is equal to 1.29 into 10 to the 1.29 kilogram per meter cube is the value for density. According to the Newton's law of speed of a sound in air, then we have the equation for V is equal to root of gamma p by rho. Already we have the gamma value which is given in the problem, that is 7/5. And after that the pressure value, what is the pressure in the air is 1.01 into 10 to the power of 5 Newton per meter square. Then after that the value for the density is 1.29 kilogram per meter cube. Then we are substituting these values, 7/5 into P is equal to 1.01 into 10 to the power of 5. Then rho is equal to 1.29 is equal to, by the calculation we can get that the speed of a sound in air at standard temperature and pressure is 331.1 meter per second. Means whenever he mentioned that the standard temperature, the speed of a sound in air at standard temperature and pressure, we should take that value V is equal to 331.1 meter per second square. Similarly, 331. The 331 will be the value speed of a sound in air at a standard temperature and pressure. So here is that when he mentioned that problem if at standard temperature and pressure the speed of a sound in air means the value will be V is equal to 331.1 meter per second. 331 meter per second. Meter per second is the unit for the velocity. This is the first problem. Next, we are going to know that the very important problem. Another one is a pipe of 30.0 centimeter long is open at both ends. That means to say it's a open pipe. Open pipe is having the length of 30 centimeter. 30.0 centimeter means 30 centimeter. Which harmonic mode of the pipe resonates at 1.1 kilohertz source? Means when in which the 30 centimeters pipe it resonates with 1.1 kilohertz resonates, then in which harmonic mode? He asked for the which harmonic mode that the pipe can resonate at 1.1 kilohertz resonance frequency. Then will resonance with the same source be observed if one end of the pipe is closed? Means he has taken the 30 centimeters of open pipe. He asked her to which harmonic mode can resonates, which harmonic mode resonates its frequency with 1.1 kilohertz. If the same source can resonates, if the pipe is open, if the source is closed pipe closed one side, means that is a closed organ pipe, then the same resonance will be occurs in which harmonic mode? In that harmonic mode. Means here the same source be observed if one end of the pipe is closed. Is the source, one end of the pipe is closed, the same source can be observed. He asked for the can the harmonic modes are equal at open and closed pipe when the pipe is resonating with frequency 1.1 kilohertz. Is it equal or not? Then first of all, length of the pipe is, we know that it is in a CGS units. 30.0 centimeter means it is in CGS units. So 30.0 means whenever we convert into the meters, then it will become 0.3 meters into 10 to the power of 3. So that's why we can get that here, that is 0.3 meters means 100 centimeters per meter, 10 to the power of minus 2 into 10 to the power of minus 2, we can get that 0.3 meters. Then let's nth harmonic, we don't know what is the harmonic. So that's why I am taking that nth harmonic. So nth harmonic of open pipe resonates means its frequency nu n is equal to 1.1 kilohertz. I don't know what is the first harmonic, second harmonic, third harmonic, fourth harmonic, fifth harmonic, I don't know whatever it is. But in open pipe, which harmonic, he asked for which harmonic will vibrate. So that's why nu n is equal to 1.1 kilohertz. That will be the kilo means 10 to the power of 3. So that's why we are taking that 1100 kilohertz. 1100 hertz. So 1.1 kilohertz is equal to 1100 hertz. Then from there we have the open pipe formula, that is general expression for the open pipe is nu n is equal to, for the nth harmonic, nu n is equal to nv by 2l. 2l be the, it is the at open pipe. Then here if we want to know that which harmonic, so we want to find out that n value. So that's why we are taking this 2l into is equal to this side of, then we can get it is multiplied with the nu n, means cross multiplication. In this case n is equal to nu n into 2l by, whenever we take it to this side it will becomes a denominator. So n is equal to nu n into 2l by v. Then if we substitute the values in the equation, then we can get, we know that nu n is equal to 1100 h. So 1100. Then here 2l, 2 into l means length of the pipe is 30 means 0.3 meter. So we are substituting the total values has to be in same units, means our SI units or CGS units. So we are taking the total values in the SI units. So that's why 0.3 meter by, we know that the velocity of a sound is 330 because of, he mentioned in the problem speed of a sound is equal to 330 meter per second. He has given that problem, already we have that value. So v is equal to 330. By calculating this one, means 1100 into 2 means here we can get 0.3 by 330, we can get that 3 by 3300. Whenever we taking this one, then we can get the value, then 1100 ones are 1100 threes are 2 ones are 2 threes are, means 6 here 6, 3 ones are 3 twos are 6. So is the second harmonic, means at second harmonic in open pipe 30 centimeters of open pipe, at second harmonic that pipe will resonate, the air column resonates at a second harmonic. At second harmonic that pipe will resonate with the frequency of 1.1 kilohertz. It resonates with 1.1 kilohertz, means 1100 hertz at a second harmonic. At second harmonic, that is a nu 2. That is a nu 2. Nu 2 means it's a second harmonic or a first overtone. Second harmonic or a first overtone that pipe. In this case, again he asked for that when will resonance with the same source be observed, means will resonance with same source be observed if one end of the pipe is closed, means if in case of a closed pipe, for closed pipe the fundamental frequency will be the fundamental frequency nu 1 is equal to V by 4L. V by 4L, we know that is nu 1 is equal to, we know that V value, that is 330. He has given in the problem is 330 by here 4L. 4L means 4 into 0.3. From that problem we can get that values. Here is that 3300 by 4 into 3, because of 3 by 10 we can get 3 by 10 whenever taken to the 10 is taken to the top, then it will multiply with the 330, then we can get 3300 by 4 into 3. These are 4 3s are 12, means here we can get 3300 by 12. Totally the value we can get that is 275 hertz. 275 means 12 ones are 12 twos are 24, 12 sevens are, and again to put 12 fives are 60. We can get that 275 hertz because of frequency. Here is that the frequency at first harmonic is 275 hertz because it is less than the 1.1 kilohertz. So that is not first harmonic. Closed pipe will not at first harmonic. If in case of third harmonic, nu 3 is equal to 3 nu 1, that is equal to 3 into 275. That means to say 3 5s are 15, 3 7s are 21, 22, 3 2s are 6, 8. So 825. This is also less than the third harmonic. So that closed pipe will not resonate at the third harmonic or first overtone. Next we can see that nu 5. Nu 5 means this is the fifth harmonic or second overtone, that is phi nu 1. 5 nu 1, that is 5 into 275. Then we can get that 5 5s are 25, 5 7s are 35, 37, 5 2s are 10, 13. Means 1375 hertz. It is more than the 1.1 kilohertz, means 1100 hertz. So that's why that closed pipe will not resonate at any harmonic. We can't observe that same value for the same source. So here is that no resonance occur in closed pipe for same source. Here is that this is the most important problem, one of the important problem in IPE examination for Telangana and Andhra Pradesh. So that's why here is once again we will discuss about it. The length of the pipe L is equal to 30 centimeters, means 0.3 meter, and which is the harmonic vibrates with he asked for 1.1 kilohertz. Then nu n is equal to 1.1 kilohertz is equal to 1100 hertz. Then from that nth harmonic nu n is equal to nv by 2l for the open pipe. We know that formula. So from that formula we should find out that the value of n, which is having that n is the nth harmonic, then the number of harmonic n is equal to nu n into 2l by v. We will modify this problem, this equation, then we can get this one. If we substitute these total values what we have, we can get the value that is equal to 2. Means at second harmonic for the open pipe, that pipe will resonate, the air column will resonate for second harmonic at 1.1 kilohertz. And he asked for this, will it resonate for the same source, with the same source be observed in one end of the pipe is closed. If the closed pipe resonates, we can get that same mode. So we are calculating this one. This is the fundamental frequency equation, that is nu 1 is equal to V by 4L. By doing this, we can get the 275 Hz will be the fundamental frequency, and this will not the 1.1 kilohertz equal to 1.1 kilohertz. So that's why at the first harmonic means at the first harmonic the pipe do not vibrates or resonates at this mode, and if we taken for the third harmonic, at the third harmonic we got the value for 825 Hz, which is less than also 1.1 kilohertz. So that's why at third harmonic or first overtone also, at that mode also, the enclosed pipe, the pipe will not resonate with the same frequency of 1100. Then after that the fifth harmonic, that is nu 5 is equal to 5 nu 1, we get the value 1375, which is greater than the what we have the problem. So what is given, so that's why there is no resonance occur for the same source in a closed pipe. If we observe that, then we can get these values. This is the equation, this is the values for whenever the open pipe and closed pipe. If in case of he asked only for the open pipe in examination, we can get that. If he asked for only for open pipe or for only closed pipe, if he mentioned that the same problem, just read carefully the problem, then we can get the solution easily. The next problem is a stretched wire of length 0.6 meter is observed to vibrate with a frequency of 30 Hz. 0.6 meter is observed to vibrate with a frequency of 30 Hz in the fundamental mode. If the string has a linear mass density of 0.05 kilogram per meter, then find, he asked for two questions, that is the velocity of propagation of transverse wave in the string. The first one, first of all, what is the given data? Given that first length L is equal to 0.6 meter, and after that he has given the frequency of fundamental mode, means nu 1 is equal to 30 Hz. Nu 1 is equal to 30 Hz. We know that what is the fundamental mode. The velocity of propagation A is equal to the fundamental mode nu 1 is equal to V by 2L. He asked for the velocity, means what is the velocity of propagation of a wave. Then what is V? That is equal to, he given that nu 1 is there and L is there, so that we are substituting V is equal to nu 1 into 2L, nu 1 into 2L, then nu 1 is equal to 30 into 0.2 into 0.6. From that we can get that 6 by 10. 6 by 10 means here is that 30 into 260 into 6 by 10. 10 6 are 6 6 are 36. 6 6 are 36. Here the 36 is the velocity of propagation of a wave. See, 36 meter per second. Then next, here next one is, he asked for tension in the string. Tension in the string means the tension T is equal, already we have the formula, V is equal to root T by mu or linear mass density M. So if in case of he asked for the tension, then we can get that the square root taken this side, then it will become T by M is equal to V square. Then he asked for the tension, so that's why T is equal to M into V square. When the M is taken to this side, then T is equal to, what is meant by the M value will be the, here is given that the linear mass density 0.05, that we can write that 5 into 10 to the power of minus 2. 5 into 10 to the power of minus 2. 5 into 10 to the power of minus 2 into 36 into 36, because we got the value for V is 36. So here is that 5 into 10 to the power of minus 2 into 36 into 36 we can get the value. This will be, so here is that 5 into 10 to the power of minus 2 into 36 into 36. From that equation we can get that whenever 36 into 36 is 1296. So 5 into 10 to the power of minus 2 into 1296. By the calculation we can get that 64.8 be the equation for the tension, that is Newton. 64.8 newtons be the tension value. Will the tension, we can get the tension value whenever the tension in the string will develop 64.8 newton tension will develop in the string. This is the value for first. A stretched wire of length 0.6 meter is observed to vibrate with a frequency of 30 Hz in the fundamental mode. So that's why we are taking that nu 1 is equal to V by 2L. From that nu 1 is equal to V by 2L, we got the value for 36 meter per second. By applying the values 36 meter per second with the velocity of propagation of a transverse wave in the string. Then after that, to find the tension, the velocity of equation whenever the wave in a tension of a string, then V is equal to root T by mu is the equation. T means tension, M be the linear mass density. In the problem we have the value for linear mass 0.05, that is linear mass M. Then from that, if we modify the formula, then we can get tension T is equal to M into V square, that is T is equal to M value is the 5 into 10 to the power of minus 2, then into 36 into 36 means V square means V means 36, so that's why 36 into 36. By multiplying this, then we can get that 64.8 newton value. 64.8 newton value with 36 into 36 will be 1296. 1296 into 5 is 36480 into 10 to the power of minus 2. Then we can get 64.8 newtons tension develops in the string. This is about this problem. Next we are going to discuss about next problem is this is the most important problem, several times got in a public examination for Board of Intermediate Education Telangana and Andhra Pradesh. So a closed organ pipe 70 centimeter long is sounded if the velocity of sound is 331 meter per second. What is the fundamental frequency of vibration of the air column? Already mentioned that closed organ pipe. First of all, we should know, take the values. What is the given data? Given that first L is equal to 70 centimeters, means already given that 70 centimeters means already we know that the values should convert into the SI unit because it is given in centimeters, so that's why 0.7 meters. And if the velocity of sound is 331 meter per second, means velocity V is equal to 331 meter per second. Then he asked for what is the fundamental frequency of vibration of air column for closed pipe. For a closed pipe, the fundamental frequency nu 1 is equal to V by 4L. For closed pipe, closed organ pipe, V by 4L is the equation. Then from that 331 by 4 into 0.7. 331 by 4 into 0.7. Then 331 into 0. Means 331 by, here we can get the value, that is 4 into 7 by 10 for the calculation. By that calculation, so in the calculation we can get 331 by 4 into 7 by 10, that is equal to 3310 by 28, that is which is approximately equal to 118.2 Hz. That means similarly we can write that 118 Hz. 118 Hz means when a closed organ pipe 70 centimeter long is sounded, if the velocity of sound is 331 meter per second, what is the fundamental frequency of vibration of the air column? He asked for the fundamental frequency of air column in a closed organ pipe. So first the length we have taken that L is equal to 70 centimeter, that is equal to 0.7 meter. Then after that V is equal to 331 meter per second. From that value, for closed pipe we have the equation for fundamental frequency, that is nu1 is equal to V by 4L, that is V is equal to 331 and 4L means 4 into L length of closed pipe is 0.7 meter. Then from that value we can, by the calculation we can get that 118.2 Hz, that is approximately equal to 118 Hz. This is the about the most important problem in the public examination. A vertical tube is made to stand in water so that the water level can be adjusted. Sound waves of frequency 320 Hz are sent into the top of the tube. If standing waves are produced at two successive water levels, of 20 centimeter and 73 centimeters, then what is the speed of sound waves in the air in the tube? Means when a tube is made to stand in water, means here is the water, whenever it is made to stand, then at the scale as to measure the length, then whenever get sounds produced, then 320 Hz, the frequency will be 320 Hz. At the water levels, two successive water levels, means if the standing waves are produced in two successive water levels, so one is the 20 centimeter, another one is 73 centimeters, then what is the speed of sound waves in air in the tube we asked about. First of all, what is the values we can write that. That is the frequency given that nu is equal to 320 Hz. Nu is equal to 320 Hz. The length of air columns produced, standing waves produced is L1 is equal to 20 centimeter and L2 is equal to 73 centimeter. Means he has given the centimeter. After that we will convert into the SI units. Then we can get that values, that is from the equation to what is the speed. He asked for the speed, means when the air columns and from the resonance we have derived the beat frequency formula, that is V is equal to 2 nu into L2 minus L1. 2 nu into L2 minus L1. From that formula, 2 into nu means 320 into L2 minus L1 means 73 is the L2 and 20 with the L1. From that formula we can write that 2 into 320 640 73 minus 20 50 centimeters is there, so we are converting it to the meters. So 50 into 10 to the power of minus 2 meters, 73 minus 20, 53 into 10 to the power of minus 2 meters. Then by the calculation 33920 into 10 to the power of minus 2 means 339.2 meter per second with the value for the velocity of a sound, speed of sound waves in air in the tube we can calculate. Means 339.2 meter per second means here 640 into 53. 640 into 53 we can calculate the values. 640 into 53, from that value we can get that so from that 33920 33,920 into 10 to the power of minus 2, then 10 to the power of minus 2 taken that 339.2 meter per second with the speed of sound waves in the air in the tube. Means when a vertical tube placed in the air water, then we can get the two standing waves at a certain two levels. That levels can get the by the values. This is the velocity, this is the speed of a sound. With the speed of this sound we can get the standing waves at 20 centimeters and 73 centimeters with the frequency of 320 Hz. Thank you.